Good morning, good afternoon, everybody. Thanks for joining us today. This is Byung-won Lee, working for Korea Association of AI Smart Home, who is hosting today's event. For this event, also, Asia Home Network Council consists of 3 Asian countries, standard organizations is also the co-hosting today. Firstly, I deeply appreciate cooperation of Econet from Japan and IGRS from China also. We Asia Home Network Council established in 2006 to sharing country-based local home network standard information. And we had been held 2 times of face-to-face meeting a year during almost 10 years. For several years, we could make the chance to meet each other for COVID-19 and focusing on the other national issues. Today, this meeting makes us a chance again to meet each other. So I'm personally very happy today. Today also, we invited the international standard leadership from CSA, OCF, and HCA also. They are working in consortium consumer market. Is different with home network supply market, but both field has a common interesting and purpose, focusing on the user service and experience. What if both market standards are mutually understanding each other and connect? Finally, the user in smart home get better the experience. It will be very exciting. Okay, let's get in the program. Let me introduce first today's moderator, who is gonna chairing the first and second session. The Han-Kyu Cho, he is working for LG Electronics and IoT connectivity standard team leader. And he has a long experience in wireless technology and standardization, in charge of IEEE 802.11 and Bluetooth and better. And he serves on the Wi-Fi Alliance as board of directors since 2013. Hello, Mr. Cho.
Hello, this is Han-Kyu Cho from LG Electronics.
Yeah, very nice to meet you.
Yeah, nice to meet you.
And thank you, many thanks for the chairing today's session. Okay, shall we get to start now?
Okay. Hello, everyone. I am Han-Kyu Cho, working for LG Electronics. I'm pleased to have a chance to moderate session 1 and session 2. And let's start from session 1, International Standards for Home and Building Electronic Systems. First presentation is public standardization for interconnection of information technology equipment, ISO/IEC JTC 1, Subcommittee 25. So the presenter is Dr. Hyojin Park. So Dr. Hyojin Park is currently working as a fellow researcher for Electronics and Telecommunications Research Institute in Korea. His interests include AIoT, artificial intelligence of things, data analytics, and digital twin. He is an active expert leading the project in ISO/IEC JTC1 Subcommittee 25, ISO TC 184, SC5, and ITUT SG20. So welcome the presenter and Dr. Hyojin Bob, please start your presentation.
Yeah, thank you, Chairman. Can you hear me?
Yes.
Yeah, I share my screen. Okay, just a moment. Can you see the screen?
Yes.
Yeah, thank you. I will start the presentation. At this session, I would like to present public standardization for interconnection of information technology at the JTC1 S25. Okay. My presentation will include the overview of S25 and their accomplishments, ongoing works, and plans. Finally, the conclusion. JTC1 is a joint committee of ISO and IEC to work on information technology. S25 is a subcommittee of JTC1 responsible for interconnection of information technology equipment. SC25 has 4 working groups. Among the working groups, the working group 1 is responsible for home electronic system coded HS. In this presentation, I'm going to briefly introduce the working group 1 activities. The scope of HS covers interface and communication protocols between devices and networks in homes and buildings, such as Econet from Japan, IJAS from China, and application of products and services, especially for energy management. The objectives of HS standard are to enable home and building occupants to live and work comfortably, safely, and economically by reducing energy consumption. This figure shows the stacks of HS standards. In HS, several heterogeneous device and service protocols are coexisted now. As you see in the middle, these are KNX, Econet, IJRS, and YBeam. To support collaboration among them, interoperability framework is defined on the application level, as you see at the top of the picture. On the right side, the HS resident gateway is specified to connect devices within and outside home. This table lists the current HS standards. The standards in yellow colored box are currently in progress state in working group 1. Japan, China, United States, Canada, and Korea are leading countries in working group 1. Now I'm introducing the accomplishment of working group since 1980s. In architecture part, several standards were published for HS architecture, home and building automation. Energy management is a very important part of working group 1. Working group 1 has published the many standards for demand response, energy management agent for an apartment complex, etc. And in user interfaces, standards were published for numerical keyboard, universal interface, and common user interface. And HS gateway is a core element at working group 1 for gateway to standard series were published. 15045 series for residential gateway by specifying its functional requirement architecture. 812 series for the product interoperability. These series define common lexicon and messaging to support interoperability among heterogeneous protocols and applications. Communication protocols are also a very important part at Working Group 1. Econet and especially are adding their new parts even now. And security standard for the security, some standard. And lastly, applications, standards for home network resource management and writings. From now on, I will talk about ongoing works at Working Group 1. Currently, Korea is developing 10192-4 series to provide interworking channels among home systems for their collaboration. The series also provide common user interface that enables the user to access all home systems through a single user interface. Japan experts are working on application protocols for storage, batteries, and controllers using Econet protocol. And China is extending their IGR series for audio remote access to smart locks. And US and Canada are working on the cybersecurity, safety, and privacy for gateway. This series identifies general principles and requirements and offers implementation guidelines at gateway for privacy, security, and safety. US and Canada also specifying for structure classes of gateway from simple and complex to fully distributed. Korea is working on energy management at Working Group 1. There are 3 ongoing works now. The first one is EMA, functional requirement and interfaces. At here, the EMA stands for Energy Management Agent. The second one is protocol of EMAs for demand response, energy management, and interacting among EMAs. And the last one is framework of narrow AI engine for premise energy management system using EMAs. I already talked about the product interoperability standard in a complement slide. And to support the implement of the product interoperability at gateway, US and Canada is extending their gateway standard now. Now I'm going to talk about the Working Group 1 plans. First, China is planning to extend their IGR series of smart lock application test and verification, access using voice control, and blockchain application protocols. And United States is proposing new project about gateway application service. This project will describe object and messages in the gateway for applications such as energy management and writing, etc. And the Working Group 1 is also considering a standard of icons for user interfaces. And recently, the energy management in home is shifting from utility-centric to the consumer-centric using EMA due to premises-based distributed energy resources, such as electronic storage system or solar panel. So to reflect this shift, HS energy management model will be revised. This picture shows the structure of EMAs for energy management. This structure was prepared by Korea and proposed to the Working Group 1. According to the structure, Korea has been proposing standard items one by one at the Working Group 1. Currently, Korea is preparing a proposal on protocol of EMAs for smart appliances. So this is the final conclusion. About 50% of S25 working group of participants is from Far East Asia, China, Japan, Korea, but their influence within the S25 seems not so strong. Now in S25, some active collaborations are in progress. For example, at North America, US and Canada, and the Europe side, to Germany and Sweden. So I want to carefully suggest the joint works of China, Japan, and Korea to S25 activities. The joint works may include the sharing information on common interest area and collaboration on development joint contributions. That's all. Thank you, Mr. Chairman.
Yeah, thank you for your presentation. Is anybody has any question, then leave it in the chat box. Still no question, but please provide your question if you have any. Okay, then I will have one question. If I understand correctly, HES is a kind of some common standard, but if I listen your presentation, some part needs to be specified for each country. So my understanding is correct?
Yes, the SF25 is a public international standard, so it is a common concept to the global market. It is not specific to the condition of the country. So each country may customize this standard to the situation. So as the chairman said, some variation may be needed to the adaptation of their country. Yeah, thank you. Yeah. Okay,
thank you for your explanation. Still no questions. So since we have 2 minutes left, so can I provide one more question, especially for commercialization?
Yes, please.
Okay, so for which product or system this HES standard is already applied?
In Korea?
In Korea, or I don't have any information, so yeah, in Korea or in any other country?
Yeah,
or...
the most typical application is as I know, the Econet and IJAR is actively working in the ST25. So they are published the standard as a JT25, and as I know, that they have the commercial products in their country. So I can say the most typical case is the Econet and IGRS. And unfortunately, in Korea, not so much the commercial product is not available now. Yeah. Thank you.
Okay.
Yeah.
Okay, thank you for the presentation. And we will go to the session 2, International Smart Home De facto Standard and Use Case. So in this session, we have 3 presentations, and totally we have 1.5 hours. So please make sure that each presentation only has 30 minutes. First presentation is Matter 1.0 specification and use case. And the presenter is Rob Alexander, affiliated with Silicon Labs. He is a principal product manager of Matter at Silicon Labs, working with the embedded software team to integrate wireless stacks into Silicon Labs hardware and software. Since 2013, Rob has served as the chair of the Zigbee Pro Core work group, and he also serves on CSA Board of Directors and the Thread Board of Directors. So please welcome the presenter, and Rob, please start your presentation.
Hello, my name is Rob Alexander, and I am the Principal Product Manager for Matter at Silicon Labs. I will be presenting a technical overview of Matter here at the Matter Developer Conference. Matter is a brand new open standard for IoT that has a huge amount of support in the industry. First, I will introduce why Matter is needed and talk about the background of how Matter came to be. Next, I will give a brief introduction about the network topology, the scope, and the architecture. After that, I will introduce the key features of Matter. We will talk about what is a Matter fabric and what is multi-admin. We will also get into some of the details of Matter's security, including device attestation. Next, we will go through the full commissioning process to illustrate how Matter securely provisions new devices. Then lastly, we will talk a bit about the data model and the interaction model. Now, let's start with the Matter overview. Today, we have seen a lot of fragmentation in the IoT landscape. Ecosystems have created their own dedicated protocols and works with certification programs. This has caused a number of problems. For consumers, it makes it extremely hard to mix and match the product you want with the preferred ecosystem or mobile app, and it becomes extremely difficult to change that ecosystem once selected. Product developers are forced to pick what ecosystem or ecosystems they support and the integrations they provide. This can lead to multiple SKUs of their otherwise identical products in order to provide connectivity to all the markets they want. This also means gaining expertise in all of those areas and navigating the different rules and requirements that they have. Lastly, on the retailer side, disparate ecosystems means they need multiple experts to procure and manage inventory and help guide consumers to the right products. This is clearly not a situation that will allow the IoT market to grow and scale. In order to solve the interoperability issues between ecosystems and devices, a unified standard became necessary. With this, Apple, Google, Amazon, SmartThings, and the Connectivity Standards Alliance worked together to start Project CHIP in late 2019. CHIP is short for Connected Home over IP and was later rebranded to Matter in May 2021. The standard is being driven by over 220 CSA member companies, including a number of extremely well-known brands. Matter is an application layer protocol and has strived to solve the interoperability between ecosystems. As an open standard, it has a number of advantages. Matter is not owned by any one company and is maintained by the members of the CSA. Matter can reduce IoT complexities for product developers by giving them a single common protocol to implement. It simplifies setup and the onboarding experience for end users. It leverages the Zigbee application definitions to provide a large offering of device type support. It has native IP functionality, allowing connectivity to any IP device locally or in the cloud. Silicon Labs has supported Matter since its inception and is one of the top 3 contributors to the open source Matter GitHub. Let's look at Matter's vision. Matter is a protocol that has simplicity, interoperability, reliability, and security as its goals. For consumers, Matter provides a more consistent setup experience across all devices and makes it migrating between ecosystems possible. For developers, they only need to develop once, and the product can be deployed everywhere. For retailers, all certified products have the Matter logo to convey they work together. This will provide a simple purchasing experience and reduce the return rate. And the great news is that the CSA has just announced the release of Matter 1.0 on October 4th, 2022. As a result of this, the Matter specification is now available to the public to download. As part of developing the certification program, Matter had a number of early adopters that went through the extensive testing program and have certified real devices. The CSA held a Matter launch event on November 3rd, 2022, where a number of those manufacturers showed off their products to the world. There are now 190 products certified or currently undergoing the process of being certified. Any new manufacturers that want to build and certify a Matter product can do so at a number of the CSA authorized test labs now. Let's look now at the Matter components. Matter, first and foremost, is an application layer built on top of the TCP/IP protocol to ensure that device-to-device functionality is discoverable and behaves consistently across different manufacturers. Matter defines its own application layer security utilizing public key cryptography with certificates and includes device attestation to ensure the authenticity of devices that communicate together. We will go into Matter security in more detail later, but this security layer does not rely upon security at the lower layers. Matter has been built with an open source first approach, and the complete reference source code is available on GitHub. You can clone the repo and use the Matter 1.0 branch for creating sample applications across a number of different platforms. The software has been extensively tested to ensure that it will be compliant with the CSA's Matter certification program. Matter's common protocol allows more devices like smartphones and smart speakers to communicate with extremely small embedded devices such as light bulbs and sensors. And because Matter devices are using IP technology, they can choose to connect directly to the cloud for enabling functionality beyond the local Matter network. Matter's hardware requirements are low and can be implemented on a number of system-on-a-chip platforms, as shown in the Matter GitHub today. The stack needs less than 192 kilobytes of RAM and less than 1 megabyte of flash for Matter end devices. Here is an example of the Matter network topology. Matter focuses on Ethernet, Wi-Fi, and Thread as the operational connectivity mechanisms. All three technologies natively support IP, and the Matter works at the application layer on top of the IP layer. Devices based on different technologies can be commissioned into the same Matter network and communicate with each other. Matter has created a well-defined commissioning scheme common to all devices. For devices with limited interfaces, this makes use of Bluetooth and QR codes to provide an extremely easy setup experience. Matter Thread devices, which are great for low-energy applications, can communicate with Wi-Fi devices through the Thread border router. For non-IP devices, it's still possible to connect a Matter network. For instance, Zigbee or Z-Wave devices can be connected to the Matter network through a Matter bridge, which is also part of the Matter 1.0 specification. Matter 1.0 supports a number of different device types. These devices have all had multiple vendors implement them to help ensure device interoperability. For lighting and electrical devices, we have simple on-off bulbs, color bulbs, switches, and plugs. For HVAC controls, we have thermostats, heating, cooling units, and fans. For sensors, we have contact, light, occupancy, temperature, pressure, flow, humidity, and on-off. For access control, we have door locks and shades. For TVs, there are media players and casting devices. For pumps, we have pumps and pump controllers. And lastly, Matter supports controllers and bridges, which includes smart assistants, mobile phones, and bridge devices to other protocols. And future versions of Matter can extend the set of devices that are officially supported. Now let's take a look at the key features of Matter. We will talk about a Matter fabric, multi-admin support, security, commissioning, the data model, and the interaction model. Unlike some other IoT technologies, the communication of Matter could happen within a single wireless technology or across different wired or wireless IP technologies. For example, a Matter device based on the Thread wireless protocol could communicate with another Matter device based on the Wi-Fi protocol. Matter's network of devices are called a fabric. A fabric is defined as a collection of Matter devices which share the same trusted root. In practice, a fabric could represent a single ecosystem. The Matter fabric can live on the same IP network as other non-Matter devices in your home, and even alongside different Matter fabrics. Each fabric is identified by a fabric ID, which is a 64-bit number. Every node in the fabric will have a unique node ID in that fabric, and nodes can be commissioned onto multiple fabrics. Matter has standardized a feature known as multi-admin. A Matter device can be commissioned into multiple fabrics and be managed by different fabric administrators. All devices are required to support at least 5 fabrics. For example, as shown by the picture on the right, the Smart Speaker 1 is the administrator of Fabric A. It can commission the light into Fabric A and then grant control privileges to the smartphone on Fabric A. After that, the smartphone A can control the light. The Smart Speaker 2 is the administrator of Fabric B. It can commission the light into Fabric B, then grant control privileges to Smart Switch on Fabric B. After that, the switch can control the light. These privileges are separate for each fabric and can allow users to try new ecosystems or even completely switch over to using a different ecosystem. Now, let's talk about Matter security. Before we get into the details, let's highlight the security principles that were a key part of Matter's design. First, there is no anonymous joining. All Matter devices are required to provide a unique passcode to the commissioner as part of authorizing the new device on the Matter fabric. This ensures that the user has proof of ownership of the device and it is not being maliciously commissioned onto a different Matter fabric. Device attestation. Every device is required to have unique device credentials that are authenticated by the manufacturer. The commissioner will read this during commissioning over the commissioning channel and validate that the device is authentic. Operational credentials. Devices are given unique operational credentials that are separate from Matter's manufacturer credentials. These credentials are managed by the commissioner and are unique across every Matter fabric. Network credentials are given only after device authentication. The Wi-Fi network key or thread master key are not given until the device has established a secure channel and its device's attestation certificate is verified. Open standard and open source. This means that the Matter standard is open to third parties vetting the claims by examining the standard and auditing the source code. Devices restrict access. Matter devices may not just communicate with any other device on the Matter fabric. Matter provides mechanisms to install access control lists that are used to delineate what controllers are authorized to control your Matter device. Matter requires all Matter end devices to have a Device Attestation Certificate, or DAC, indicating its authenticity. This is unique to every single Matter device that is created. The certificate chain has a 3-level tier. The bottom level is the Product Attestation Authority, or the PAA. The PAA will be used to sign a Product Attestation Intermediate, which is the PAI. The PAI will then be used to sign the device attestation certificates. During commissioning, the DAC will be transferred to the commissioner and verified against the DCL. It is important to note that there is no single root PAA across all manufacturers. This will greatly reduce the chance of a compromise impacting all Matter devices. All right, now let's get into commissioning. There are 2 main starting points when commissioning a device. First is a case where the device is already on the same IP network as the commissioner, and the second is where the device is not on the network and needs credentials. Option A is the most common use case for rich UI devices like TVs and thermostats. These devices may be put onto the user's network regardless of whether a user wants to control them with Matter. The devices have the ability to configure the Wi-Fi or Thread network manually through some manufacturer-specific means. It could be an on-screen display and remote, or a manufacturer-specific mobile app. Option B is the most common for limited UI devices, such as smart plugs, bulbs, sensors, shades, and switches. In this case, the devices need to support BLE. Now let's look at the 3 main commissioning flows. Standard commissioning is when an uncommissioned device will automatically boot up and start advertising that it can be commissioned. This is very beneficial for device types like light bulbs and sensors. User intent is used for device types that still have limited interfaces, but that have a desire for restricting commissioning. One of the best examples would be a door lock. Lastly, there is a custom flow that is used for devices that need manufacturer-specific mechanisms to enable Matter. This allows the device to indicate Matter support to the end user, and through some of the standard Matter mechanisms, guide them to the right way to access the Matter functionality. For example, the thermostat could be on the user's Wi-Fi network and advertise its Matter capability. A Matter commissioner can recognize this and, reading a URL from the device, direct the user to a web page indicating what to do to update the thermostat's firmware. Let's dig deeper into the commissioning flow. There are three main parts. First, we start with establishing the initial security. Step one is we need to have the Matter device enter into commissioning mode. We will focus on standard commissioning and user intent commissioning. The user will perform the requisite steps here to trigger the device to be ready to be commissioned. Regardless of the means to get into commissioning mode, it will time out this operation after a few minutes and refuse to accept a new commissioning until it is started again. One of the most typical scenarios for commissioning will be using a mobile phone as the commissioner. The next step is that the commissioner must obtain the Matter passcode from the device. This can be done by scanning the QR code or entering the Matter passcode manually. The next step depends on whether or not the Matter device is already on the user's Wi-Fi or Thread network. If the device is already on the network, it can be discovered using DNS-based service discovery. This might occur, for example, with a TV or thermostat, where the user has already set up the device on their home network and wants to just add it to the Matter fabric. If the device is not on a Thread nor Wi-Fi network, then it can make use of BLE to advertise that it is ready for commissioning. The mobile phone will scan for the Matter BLE beacons and then establish a Bluetooth connection to the device. In both the case of BLE and a device already on the IP network, the next step is to establish a secure channel using Matter's Password Authenticated Session Establishment, or PACE. Using the Matter passcode, a cryptographic session will be established using SPAKE2+ and the NIST P256 curve. As part of establishing this channel, both sides will securely verify the partner device has the device's passcode. The next part is installing the new Matter Fabric's security credentials. After the PACE secured connection is established, the commissioner will first need to verify the manufacturer certificate and the device compliance status for the Matter device. As we mentioned before, each Matter device is required to have a unique device certificate. The commissioner, in this example the mobile phone, will read the device certificate through the commissioning channel and verify the device is in possession of the associated private key. Then it can communicate with a remote database to validate the device certificate chain and the compliance status of the device. The remote database is called DCL, short for Distributed Compliance Ledger, and is managed by the Connectivity Standards Alliance. Next, the commissioner will install the operational security for the device. The device will generate a public-private key pair and create a certificate signing request for its public key. The commissioner creates a new operational certificate with the associated device's public key and returns this to the device. This could be done locally on the commissioner, or it could be done using a secure service in the cloud. Matter allows for both. Along with the operational certificate, the device is given the commissioner's root certificate and an access control list with a set of authorized administrators. Once we install the operational security on the device, we can configure the operational network for the device. If it does not already have this, for Wi-Fi devices, we will configure the SSID and the password. For Thread devices, the commissioner will configure the PAN ID and the Thread master key. Now we have the final steps for commissioning. The device can use the network credentials obtained to join to the operational network of Wi-Fi or Thread. Once on the network, the commissioner will verify that the device can be discovered on the IP network using the DNS-based service discovery. At that point, it will perform Certificate Authenticated Session Establishment, or CASE, to create a new secure channel with the previously established operational credentials. case may also be performed at various other points to reestablish security credentials to the commissioner or other devices on the network. Then comes the final step where the commissioner can send the finish message. Commissioning is now complete. Any application configuration or operational function can additionally be performed using the Matter application clusters. Let's switch gears to talk about the data model. Matter's data model leverages the Zigbee cluster library and ... both developed by the Connectivity Standards Alliance. If you are familiar with Zigbee, then it is easy to understand the Matter data model. In the Matter data model, each logical unit is represented by an endpoint. Endpoints are generally associated with a device type. Within the endpoint, there could be multiple clusters supported. Each cluster defines a specific function and includes attributes, commands, and events. Let's show you an example of a lighting product. The lighting product may have endpoint 1 that represents a dimmable light device type. This endpoint contains 2 clusters. Cluster 1 can provide on-off functionality and state attributes. Meanwhile, cluster 2 can be the level control cluster for controlling and querying the light's dimming settings. The lighting product could also have another endpoint for a different device type, such as a temperature sensor. This sensor has its own supported clusters, attributes, and events. The interaction happens between local endpoints and remote endpoints in a client-server data model. Please note that it does not perfectly match Zigbee and was extended for the new functionality needed by Matter. Clusters are based on a client-server model. There are attributes, commands, and events defined in the cluster. Each cluster is an abstract of a function. For example, the on-off cluster can be used to implement the on-off of a light, the on-off of an electrical socket, and an on-off of a TV, etc. The level control can be used to implement the level strength adjustment, such as brightness, speed, strength, and more. There could be attributes defined on the client side or the server side, or both. Normally, it's on the server side. Some of the attributes might be fabric scoped. Most of them are security-related attributes. For example, you can connect your door lock to 2 ecosystems at the same time and use 2 different PIN codes for the 2 apps. Client and server can interact with the predefined commands. The commands mostly work in a request-response manner. An event is a special command. It's an unsolicited command, and most of these are notifications. Matter products may contain 1 or more device types. Device types encapsulate a logical grouping of different functionality. Their functionality may overlap with other device types. Users are meant to easily understand a Matter device type as it relates to many mundane devices in the home. Meanwhile, the Matter protocol can provide specific information to the controllers that need to manipulate clusters across multiple devices. Let's take a look at the example of a color temperature light. The color temperature light has the Identify cluster, the Groups cluster, the Scenes cluster, the On-Off cluster, the Level control, and the Color control. A basic white dimmable bulb would have a similar set of clusters, but wouldn't have color control. Meanwhile, a smart plug doesn't have dimming capability using the level control cluster and only has the on-off cluster. However, a Matter controller, at a minimum, has the ability to manipulate them all using the on-off cluster. Matter also provides the possibility of working with non-Matter devices. This is possible through the bridge model. The bridge on the Matter side must have an IP interface and respond to all Matter-related messages on behalf of its devices. To the Matter fabric, it will appear as a single physical device, but through multiple endpoints, all devices operating behind it using non-Matter protocols can be accessed. The bridge device will have a dual identity to proxy the Matter communications and translate them to the non-Matter protocol, and vice versa. Depending on how device types, commands, and attributes are presented by the non-Matter protocol, this may map to 1 or more endpoints on the Matter side. As we introduced in the previous slides, the device communications happens between 2 endpoints. These communications are called interactions. An interaction can contain 1 or more transactions within it. Within a transaction is a set of actions. The actions are messages containing the data or commands from the data model to operate on and are generally pairized messages of a request-response nature. A read request is sent to read attribute data and is responded to by a report data action. A subscribe request is a request to gain regular updates to an attribute and is answered with a subscribe response action. An invoke request is a request to execute a command on the target and is answered with an invoke response. A timed request indicates another action will take place within a timeout period. A status response is a more generic response used to answer certain common error cases or is sent in response to a timed request action. An action contains a path to the data to operate on. This data is encoded in a series of information blocks. The most common one is an attribute path IB. This in turn contains a cluster path IB that contains the cluster ID and either a node ID and endpoint for unicast messages or a group ID for groupcast messages. Lastly, a command path IB contains a command to invoke along with the endpoint and cluster. Let's see an example. This interaction contains a write, a read, and an invoke transaction. The write transaction has a write request followed by a write response. It then has a read request action followed by a report data action indicating the value or values of the data read. Lastly, the invoke request indicates the command to invoke and is followed by an invoke response. That concludes the Matter 1.0 technical overview. Thanks very much for taking the time to watch this presentation. I hope you have learned enough to get started with your own Matter development.
Yeah, this was the recorded version, so we can't have a question, but if you have some question, then you can do that in the discussion session later. And we will go to the next presentation. It's OCF 2.2.6 specification and use case. And the presenter speaker is Brian Bishop. He's CEO of Data Performance Consultancy Limited, a niche consultancy and technology service provider based in Liverpool, England. Brian has been carrying out research in smart cities for over 8 years, and more recently looking at the convergence of the digital twin as a foundational building block to developing smart cities. Welcome the speaker, and please start your presentation.
Good morning. Can I just we assume that the presentation would be provided by yourselves, and then we would run through it. But if you want us to share, then we can do that now. Thank you. Good morning, everybody. So my name is Brian Bishop. I'm president of the Open Connectivity Foundation. I'm joined on this presentation by my colleague Bruno Johnson, who is managing director of a company called Cascoda in the UK. Has been working extremely hard on the development of technologies in this space, and is also chair of the OCF marketing strategy work group. What we'll do is Bruno will start the presentation and I will finish the presentation as we move forward. Bruno, can I hand over to you, please? Thank you.
Hello, thank you, Brian, and thank you, Chair. So today we are going to go over a brief overview of what is OCF, what IoT device connectivity methods does OCF enable, what is the secure IP device framework of OCF, and what are OCF data models and OCF code generation, the benefits of joining OCF, and how can OCF standard benefit Korea? Okay, so what is OCF? OCF is an ISO IEC standard protocol for IoT. It's fully compliant towards a RESTful architecture and has built-in discovery and subscription mechanisms. OCF source implementation allows flexibility in creating solutions. It allows all types of device form factors, companies, and markets of wide interest to collaborate. Certification and interoperability testing is a very important part of OCF. We have a three-pillar model where the specification, the open source stack, and the certification tooling are constantly tested against each other. So what IoT device connectivity methods does OCF enable? So first we have the simple client-server model. Remember, the client server can be on the local network across multiple different IP device types. We have the client to bridge model. So this is for non-IP based protocols such as Bluetooth. And then we have device to cloud communications and even cloud to cloud communications. So it's possible to using OCF to allow for communications across secure communications across multiple cloud-based systems and even across multiple geographies with different legislative requirements. So what is the OCF Secure IP Device Framework? So the Secure IP Device Framework is an ISO IEC infrastructure that enables secure IP communications of the defined application. It's vertical agnostic, using secure IP communication backed up by PKI certificates. It's backed by a fully open source implementation, which is compliant to the standard and includes verification of the implementation through a strong certification program. The framework is compliant with most of the known IoT security requirements baselines, and we have a full table showing the comparisons of the standard to the IoT security baselines. It contains device discovery to discover devices on the network, and this can go across multiple IP segments from Thread to Wi-Fi, for example. And security using DTLS. We have onboarding on the secure domain using a OCF onboarding tool, and using PKI certificates, we allow for access control lists for granular control of who is allowed to do what on the device. The technology is made up of a basket of IETF specifications. We support all the Internet Protocol-based physical layers, Wi-Fi, Thread, Ethernet, 4G, 5G, and there are devices certified even with Thread. It's based on IPv6, UDP, TCP, DTLS, messaging using CoAP, encoding uses CBOR, and the device model framework using OAS 2.0. With OCF, you can effectively compile your compliance to the regulatory baseline IoT security standards. We've done an awful lot of work to compare every clause of the OCF specification with all the main global IoT security baselines. And this information is public and on our website under the security page. So you can see exactly where we comply and exactly where a area is not met, but generally the areas that are not met are due to out of scope activities. So let's look at the data modeling and code generation. So first of all, the data models use the open API OAS 2.0 infrastructure. The payloads are defined in JSON, and payloads are described by means of examples in a JSON schema. So it is quite straightforward to create your own data model and request that that be added to the specification. And crucially, the IP device framework does not mandate that you use OCF's data models. You can use your own data models. There is no problem with that. All the OAS 2.0 files are on GitHub, so easily accessible and usable. Currently, there are 85 device types defined and 180 resource types defined. But this list is going to get a lot bigger because we have a collaboration with the FIWARE organization in Europe, which has a lot more data models for smart city. Code generation within OCF is an important feature. This allows the user to automatically generate the target code that will go on a device, including an embedded device. This is a very useful feature because it takes away some of the low-level compilation and definition work for embedded devices that some users might find quite complicated. And there is a device builder toolchain that goes along with that greatly simplifies the process of creating a set of code for a particular device and a particular application. So for the benefits of joining OCF, I will hand back to Brian and allow him to take the rest of the presentation. Thank you.
Thanks, Bruno. So what was the whole point of OCF? Well, it was to build an ecosystem that is co-creative and, more importantly, open. And in doing so, it facilitated an ability for cities to think about how it can create inclusive growth, whereby they can think about how to incentivize new business ideas based on the challenges that they face, and how they can include all types of business, not just the tier ones, but also the SMEs. The ability to scale is one of the key barriers that SMEs face. But by learning from larger partners and allowing cities to support a living lab scenario, whilst also providing support mechanisms for scaling new businesses, this can be achieved, thereby allowing city leaders to build capability and capacity, because these are some of the prerequisites of new strategy and new policy. New slide, please, Bruno. So one of the key areas that OCF has been working on is to help city leaders build this ecosystem model and to provide the tools needed to support the private sector, and more importantly, for academia to work with new businesses to accelerate their own growth. The support of universities is a very important area as it links new research opportunities by providing guidance and access to the libraries that OCF provides as open source. Students can carry out credible research and, more importantly, think about how this holistically feeds into a more federated infrastructure. We have seen in the UK new ideas being generated in this way. And this is based on a cyber-physical infrastructure challenge. This has really been the mainstay of the UK's future strategy around the digital twin. Next slide, please. So as Bruno has mentioned earlier, the technology aspect of OCF is very mature, and we are now looking forward. And this is very much about how we build new applications that the standard can be applied to, and how smart cities and the digital twin is certainly an area that we are focusing on. We believe that cities need help in identifying the right technologies and how this can be done in a way that is non-proprietary and allows them to also scale their own ecosystems. OCF can do this, and we are working on the rebrand of the organization to move towards this direction, with the concept of a smart city marketplace filled with sensor technologies that support each and every vertical of a smart city landscape, and more importantly, provides the interoperability, the security, and the governance frameworks that cities need. I'd just like to think a bit more about this marketplace concept, because the creation of a marketplace for trusted technologies is part of the reasons why mayors all around the world are now thinking about how they build their own infrastructure. So if they had a marketplace of technologies that have already been certified and proven, it assists them in developing their own policy. Next slide, please. So what does this mean? The smart city space has failed in many areas, more notably in the areas of data. OCF have been working hard with other open standard bodies such as FIREWare, as we mentioned before, in building the data models needed for interoperability. In essence, most cities failed in their smart city strategies by moving too quickly into the technology phase, without realizing that data lakes could only develop predictive models rather than reactive models. And more importantly, the social aspects of smart cities, i.e. the sharing of data, was not mature enough. OCF over the last 3 years has been working towards this strategy. But by having an open ecosystem, we can make sure that the ethics around the data usage is paramount in the thinking of how we build the applications of the future, and why we believe this supports South Korea's vision of one nation, and how they can support the new entrepreneurs of the future without relying so heavily on the tier 1 organizations. Next slide, please. The need for demonstrators is key to all of this. And as president of OCF, I've been working hard to emphasize the need for this in the UK. And I am aware of the strong collaborative relationship between the UK and South Korea. The concept of connected cities is being heavily promoted, and this can only be achieved through common standards. By building the technology stack based on an open standard allows a bilateral approach to export potential. And this is very important given the free trade agreements that the UK and South Korea has. But this is not confined to these two countries, as there is huge potential across the ASEAN region and certainly within Europe. This is all now expanding heavily. We believe that OCF has a strong market in the commercial space, but it must be said that the development of the smart home is also gaining further momentum with the concept of domiciliary care. This is a really important area, as the need for highly secure device management for health monitoring and the ability to interact with appliances being crucial in care at home scenarios. So these are progressive areas that we are looking into. Next slide, please. However, this model is predicated around the ethical use of data from a device to the edge, to the cloud, to a validated and responsible person. This data pipeline is key in the creation of real-time information, and as mentioned is the foundational building blocks for the creation of the digital twin. So if we can provide that provenance model to researchers, which utilizes a data commons, then we gain insight and, more importantly, provide an approved code of practice for not just predictive modeling, but also real-time operational workflows. And subsequently, the development of machine learning algorithms that are transferable, which is ultimately how AI of the future can be assured. Next slide, please. And again, please. Here are some of the learning resources that OCF provides. Again, we would ask, for you to review these. We are looking for new members. We want to build this ecosystem further, especially in the areas of academia. And we also believe that in the future, there are huge opportunities around connected city programs, utilizing, not just OCF, but other standards such as Fireware, Oasis, etc. Next slide, please. Again, if you wanted any further information, please see the details above. And thank you. If you have any further questions, please don't hesitate to ask. Thank you.
Yeah, thank you for the presentation. If anybody has any question, then please leave it in the chat box. Okay, firstly, it's very good to hear about some update on OCF, because I also worked for OCF for several years ago, so it was very good. And I have a question. In your presentation, you mentioned that from the perspective of technology, OCF is very mature. So nevertheless, OCF has its own technology development plan, or instead of technology development, OCF is more focusing on pursuing some commercialization or some ecosystem expansion. What's your OCF's future plan?
So, as mentioned, we believe that the OCF standard is quite mature. It will be iterative. It still will evolve, but it will evolve based on the challenges that we face. So moving now into a commercialization mode, and thinking about how we build, the smart commercial space and the smart home space, we will identify further challenges to, things like security, and data ethics. So that's why we believe now it is important that we start to build the products and services that city leaders need, and work with city leaders, because that way then we get the stakeholder engagement, and then that will then derive further challenges for the actual technology behind all of this.
Okay, thank you for your answer. And can I have one more question? Actually, you say about something in UK. So could you more elaborate on what's the status and plan of matter of OCF in UK?
Yes, certainly. So I personally sit on the UK's panel of experts for smart cities. So I've been promoting the use of open standards in the UK. The UK has set out its cyber physical infrastructure strategy, and the use of open standards now is dominating that area. So I've been working with BASE and with DCMS in carrying out discussions on how OCF could be utilized as a demonstrator model within a city. And one of the key areas that I'm looking for is the development of a connected twin. So the city of Liverpool is a city that is looking to become a smart city, but through the use of open standards. And we're working very hard with the Science and Technology Facilities Council to develop funding programs to start that phase. And I think the area that we're focusing on is the creation of connected ports. I know that there is already ongoing discussions within the UK through the Connected Places Catapult to link the city of Busan with the city of Liverpool. And through the use of open standards and common data models, we can start to think about how we create connected ports using these standards and develop, opportunities for businesses in South Korea who are building technologies to, export that potential to the UK and vice versa from the UK back to South Korea. This then explodes the opportunity for export potential across the ASEAN region. So that's certainly an area that we are heavily focused on.
Okay, thank you for your explanation on UK's plan on OCF utilization in smart city. Thank you.
Thank you.
And if there is any other question, then we move to the next presentation. It's a last presentation in this session. The title of presentation is HCA Home Connectivity Alliance 1.0 Specification and Use Case. And presenter speaker is Yoon-ho Choi, affiliated with Samsung Electronics. And he is Home Connectivity Alliance President and Board Chair. And he is also working for Samsung Electronics, Global Head of Planning and Partnerships, IoT Business. Please welcome Yoon-ho Choi, and please start your presentation.
Thank you very much, and thank you for the organizers to invite HCA, I think, to this important session. I think, let me, before I jump into the presentation, I think the HCA is probably the youngest and the smallest, organization here, right? So we are, less than a year old. We launched the organization in January, at CES this year, right? So, we are still a young organization. And I think, today's presentation, I think there's a lot I can talk about, but I think one of the important things I want to maybe, emphasize is why such an organization should exist on top of all of these other, mature and well-developed organizations and standards, right? And I think providing that point of view will help, with providing some clarity on why we have formed such an organization. So I look forward to this conversation. Let me share this file. Can you see my screen?
Yes, we can see.
Very good. So yeah, as I mentioned, I think, why such an organization was shaped, what are we trying to do, and how does it operate? I think these are the kind of the key things to present to you. this is probably the summary slide that captures, everything I'm going to talk about, right? So HCA, Home Connectivity Alliance, is an alliance that's primarily focused on the large appliances in the home, right? So all of these brands you see on the left here are manufacturers of either, home appliances, HVAC, or TVs, right? And so our industry is not made up of hundreds of companies. In fact, it's made up of, just a handful of companies that really kind of play in the global market, right? So our aim is not to be hundreds of members, but really to focus on, IoT topics that impact the large appliances, the appliances that you use every day, as well as, devices that stay in your home for, anywhere from 5 to 15 years, right? So it's a long life cycle category. Our focus is two things, right? First one is interoperability. So all of us today, all of the brands on the left here today, we have our separate apps, separate cloud systems, separate ecosystems, right? Our goal in 2022 is only one thing, is to make sure that any app from these brands can work with any of the devices from these brands, right? So any app to any device is the goal for 2022. And we've only focused, squarely on this. As we go into next year, right? As we start rolling into 23, our focus will expand to include sustainability, right? So sustainability for our industry really means, the ability to manage the energy in the home in an intelligent way that includes multiple devices from multiple brands, right? So no home is, only single brand, right? So my home has, some Samsung products, some LG products, some Electrolux products. And so making these work together, in the goal of energy management, we think that this is our way of our opportunity to contribute to, a better environment, and then really just cost savings for the consumer. So this is sort of the summary slide that I will talk about. From an appliance, everything I'm going to present to you, please think of this from an appliance perspective, right? From the large appliance perspective, right? So from our perspective, the digital landscape is changing, right? So many of our companies have been around, well over 100 years, right? So, there are no real young, super young, appliance companies in our membership today. But many of us have been around before, computers really, so, but the landscape is changing, right? So the ecosystem with AI, machine learning, with, the cost of connectivity so low now, all of this is, really kind of expanding the ecosystem. We think that there's a blurring of boundaries between, hardware and platforms, right? So a lot of our hardware, will trigger or will enable different services from different platforms, right? So we work with these platforms. And so these devices are no longer just washing your clothes or cooking your dinner, but it's actually triggering different types of interactions, whether that be management, that be, energy, and then, of course, extends into commerce, right? So as we see it, the block on the right here is there's a few options for, large appliances, right? So one is to stay with our current, closed ecosystems, which really doesn't scale, right? And it creates a pie that's too small. We can also work with, third-party controlled, or platforms and completely rely on that, which then there's a risk of, hardware commoditization, right? And this is something that, from a competitive standpoint, from a healthy industry standpoint, is something to think about. And I think, the path we are heading is to be able to, number one, interconnect all of our hardware platforms, all of our ecosystems, and then really do this with a very narrow focus, right? So our goal is not to reinvent the connectivity layer. In fact, there's many, OCF, Matter, and a bunch of other, great connectivity protocols that we are also part of, right? So a lot of our members are also part of these, organizations, and we support that. So our goal is not to, reinvent the connectivity layer. In fact, our goal is to leverage the existing systems that we have today. So for today, we're going to squarely focus on cloud to cloud, right? And there are specific reasons for that, and I'll get into that in a minute. So connectivity layer, reinventing that is not our focus, okay? Large appliances, I think one thing to, some of us who are already here, may understand this, but, large appliances do have unique requirements, right? And when you think about, devices other than probably your car, these devices are the largest devices, connected devices in your home, right? So the refrigerators, the washing machines, the HVAC system, right? So these systems, these products have sometimes moving parts, they have heat and compression, right? And so there's a physical safety layer that we need to be attentive to, right? So even as we move into the digital landscape, we're extremely sort of cautious about how we approach here. Another aspect is that, these devices are in your home for a long time, right? So our ability to support legacy devices is a key requirement, right? So as exciting as IoT is, if I have to tell you that you have to go out and buy an entire new kitchen, it's a different sort of mindset, right? So we plan on supporting our legacy products, and we want to make sure that there's a smooth transition, that we can continue to support our products, whether it's warranty or servicing or any of those things, and make sure that it's supported. We do think that there needs to be a dedicated forum for these large appliance manufacturers to come together and talk about issues and topics that impact our industry. Now there are other trade organizations. It could be Aplia or AHAM or other larger trade organizations which we're also part of, right? So, and I've spoken to all of them, right? So and the key thing is that our focus is very focused only on the IoT aspect and not just general, energy or general sort of safety like this. We do work with, many governments, and we work with different regulatory bodies to make sure that, that what we do here complies, and we can in fact lead the way as it relates to, data privacy, as it relates to cybersecurity and so on. So we support that, and we are actively conversing with these organizations, okay? If we think about kind of what's our goals here, right? And if we think about it from a two-layer perspective, right? One for consumers, one for the industry, right? So for consumers, I think it's, because these are devices, not only, people on this call who are, well-versed in technology, but like these are products my wife, my mom uses all the time, right? So we want to be able to leverage, and so that they don't need to switch around from different apps to control different devices in their home. They can use whatever app they want to use and then be able to control devices, large devices in their home. So that's kind of, a simple but an important goal for us. For consumers, energy management is of course a hot topic right now. But, and people ask me, they say, well, how did HCA know that energy was going to be, such a topic, right? We didn't. But energy, if you think about the large appliances, is always been important, right? So between appliances and HVAC and water heaters, that constitutes about 75+% of the load in the home, right? So we want to be able to intelligently, reduce that in lots of different ways. So we have an energy, task force that's chartered to do that, but without compromising comfort, right? So if I'm an HVAC company, of course, the simple way to do it is just to turn off the AC, right? But that's not a viable sort of path either, right? So we are working with different algorithms and different mechanisms, working with utility companies, working with energy solutions providers, to do that in a smart way so that the impact in your daily life is not impacted. As I mentioned before, I think for the industry, this is a forum for us to have a very open conversation about, what can we do we are all competitors, right? But what can we do to help, our consumers save money and really enjoy the luxury of convenience, right? And so we are working on this. I think the other important thing is, to be a kind of a voice of appliance manufacturer in the digital landscape, right? So I think oftentimes there are lots of new regulations that impact our industry. So we want to make sure that, this is properly voiced, and we are actively engaged to make sure that, those things, work in a way that we can actually, adopt it, right? So that's our simple goal, okay? As I mentioned before, the C2C focus is kind of where we are, right? So it could be any app to any device. It's a simple, I'm not going to go into the technical details because I think the cloud-to-cloud interface that we're, using is the standard one, right? It's OAuth 2.0, the common data models, common API, and then really in terms of even certification, it's a self-conformance model, right? So we are all adhering to many different types of cybersecurity certifications today anyway, and so we have a very simple approach, a very light approach to actually get this working. We have today 15 products in our scope, okay, 15 product categories. And then it composed of, just over 40 different features or capabilities. And the reason why we do this is, from years of data, we understand that it's, we may provide 100% of the capabilities, but really in the end, the capabilities people use most frequently is a very small set. So as we begin, we are focusing on the top 20% of the capabilities that 80% of the consumers use today, right? So, we're not trying to pack every capability into our specification. In fact, I think what we are doing is being a little humble and saying, we will grow with the consumer, right? So they will let us know what additional capabilities we need. The nature of our industry is a very long game, right? So we plan to grow this way, okay? Energy management is an extremely important topic for us, I think, because of again, the nature of our category, and because it's a very sharp, pain point for many consumers today, right? If your home has only one brand and one, set of products, the HCA may not be that relevant for you. But if your home has, more than one brand, right? And if you have devices from different, different brands and different categories of product, this will help you save money, right? So we are exploring lots of different business models with, aggregators, with different, energy solutions company working towards really kind of a net zero home, right? So that is the ultimate vision. There are many steps to get there. And so this is where we focus. If I look at the energy a little bit more detail, it's a pretty straightforward model, right? So our brands, our products, with the common data set and common API can interface with many of these energy companies. And for the energy companies, really, instead of developing lots of one-off, connections with lots of different companies, the ability to connect once and then be able to connect with a host of products or brands really kind of reduces their overall load, and there's consistency, right, on how the devices behave in a demand response situation, and so on, right? So the feedback and the sort of the engagement from the energy companies have been very engaging, very, very, there's a high interest, right? So we want to work with them to create a win-win situation for our consumers, for us, and of course for the energy providers, right? And the nature of working with these industries, right? So while we are not trying to adopt all of this into HCA spec, in fact, what we want to do is we want to work with different energy standards that are out there, different energy solution companies, so that we can maximize and grow this. The way we think about this is that the IoT, especially in the large appliances, it still is a very small portion, right? So when I meet with the CEOs and with the brand CEOs, I mean, the landscape is still in the, like 15, 20, 25% range. That's a very small pie for all of us to, continue to compete in without, if we don't grow it, nothing's going to happen, right? So I think the goal is not to compete on today's sort of landscape, but what can we do to increase the overall pie, by tenfold, right? So that's kind of our goal. Organization's pretty streamlined. We have, of course, the board, and today we have 3 working groups, right? So we have the marketing working group, technical, and the legal working group. As I mentioned before, the legal is quite important for us because we work with different regulatory bodies. Technical working group, of course, has these 4 components, right? So we have the data model, API, and cybersecurity, and then a recently formed energy management TF, right? So, based on each of the scope of the TFs, they will continue to work on the spec. Our spec will be complete by the end of this year. And at CES, we will have presence at CES. And on January 5th is when we will release it to the industry. And so it'll be available for everyone to see and to, consider, okay? So this is our timeline, right? So if you look at it in a kind of a simplistic view, 22 is all about any app, any device. 23, we're going to really drill down into the energy management aspect and what businesses can come from this, right? For all of us. So this is how we approach it. So from, this year CES to next year CES, which is coming up in a month, we hope to, move very, very quickly. We are small, and so I think the ability to almost work like a startup, right? So we work very intensely, but I think this is why we are able to get this far. Of course, our leaders, right, and the leaders from our industry, LG and Electrolux and many higher, and all of these companies are experts, right? And they are helping to lead the way. Okay. Yeah, we recently at IFA in Berlin had a private gathering, an invite-only gathering where we had all the leaders from the companies come together, all the CEOs come together. We had different government organizations, of course, media come together to really to have a checkpoint to say, are we headed in the right direction, right? So we were able to confirm this. For me, as the president of HCA, this is quite important because, the nature of our organization is that we are competitors, right? So having the CEOs, be able to support this on a CEO level is extremely important. I think that's the way to accelerate adoption and to make this happen, right? So I am very upfront about the competitive nature of this and, what we gain as we collaborate, okay? Yep. This is, I think, the last slide. So we will have a booth at CES. This is a beautiful product by LG. We'll have a bunch of devices here, so please come if you are in CES and in Vegas, and I'd love to connect with you to discuss further on any questions you may have. Okay, thank you.
Yeah, thank you for the presentation, and nice to meet you again. Actually, LG is also working for HCA, so we had some discussion on.
That's right.
Yeah, HCA. So anyway, nice to meet you here. And as the speaker mentioned, compared to the other standard like Matter or OCF, HCA is younger and is more based on large home appliance companies. So probably you guys might not be familiar with the HCA. So if you have any question, then please leave it in the chat box.
Yep. And I'm, in Korea, so I'm in the Asia time zone. So, I speak with a lot of, potential members from Japan and China. And, we are a global organization. So it's an exciting time for us. I think there's a lot of challenge for us. Oftentimes, I think one of the things last point I want to make is, especially when reporters talk to me, they always kind of do this like, oh, HCA is this competing against something, or it's deviating from something, it's fragmenting from something like this. And because from a reporting standpoint, a collaboration story is okay, but a fight story is always more fun, right? So I often get this, but I really want to mention that, OCF with Matter, all of these standards we have been part of, or we are already part of, right? So from an appliance manufacturer's perspective, for us, fragmentation and this is actually painful, right? We don't want that. But we also know that there are very specific requirements for larger, appliances. And I think we're just kind of coming to terms to say these, are things that we need to address. People ask me, they say, well, is this all going to merge in the future, right? Is it going to be kind of one and you're going to, become part of something, right? I don't know, but I leave that completely open. With Matter, for example, I often talk to their management very frequently, and I talk to the CEO there quite frequently, and we are thinking about how do we create a path so that this is, not so fragmented. With the OCF, with Brian and I'd love to continue to chat as well too, right? So I'm always open to chat and to see how we can collaborate, because in the end, think about it this way, IoT is exciting, but it's been exciting for like 20 years. If your mom and your, grandmother and your wife and, husband, if they are not using this, then it's never going to be mass scale, right? So let's kind of work towards that direction, make it and everybody, every day. That's kind of our focus. Okay. Thank you very much. Thank you very much for your time. Yeah.
Okay. Thank you. So it is the end of this session, and thank you for listening to all the presentations, and thank you.
Thank you very much for chairing this session today, Mr. Zhou, and I believe this is very fruitful for the industrial members, China, Japan, also to the Korea, the enterprises. Okay, let's have a 10-minute break, and we will come back exactly 3 p.m. See you again. Okay. So let's start for the next session. The Professor Seom-Kang from the Gyeonggi University will take a third and discussion session now. Seom-Kang is now working for a professor at Gyeonggi University Computer Science Department. He is actively participating in standard activities in ISO/IEC JTC1 SC25 and 412 and 42 or so. And also in ITU and CA, he is working now. He is now focusing on the intelligent energy management issues for home using AI technology, and he is an editor of AI framework also for home energy management standard at SC25 working group 1. Okay, hello, Professor Kang. Good to see you.
Okay, thank you, Mr. Byung-han. Good afternoon, all the speakers and participants from different countries and organizations. I'm Seom-Kang, session moderator for the session 3 and discussion after this session. We have 3 speakers in my session. This session is mainly focusing on the Asian home network standard, their status and use cases. If you have any questions about the presentation, just write them at the chat box, then I will take care of that. Now, I will introduce the first speaker. The presenter is Dr. Hak-Jin Lee. Currently is working as a senior researcher for Electronics and Telecommunications Research Institute, ETRI, Korea. His interests include AIoT, artificial intelligence of things, middleware, data analytics, and digital twin in smart factory. But I've heard he will use the recorded material, so please play his recorded materials.
Nice to meet you. I work for ETRI, and ETRI is a CASH member. ETRI is a research institution about electronics and telecommunications. CASH is the Korea Association of Smart Home. I will start the presentation. My presentation is the status of Korea Smart Home through standard and use case. In this presentation, I will talk with 3 agendas. The first is the Korean smart home market. Korea smart home has been continuously growing since 2000. In 2022 year, 23 trillion won. In dollar, that is 23 billion. The smart home automation market, excluding expensive home appliances, account for only 2.9% in 2022. However, Korean smart home automation provide convenience and comfort to the people at a low price. In the respect, I think the smart home standard is an important standard. The number of households in Korea is 23 million. Smart homes are already used by 8 million as households, and 400,000 app households are installed every year. In Korea, many people live in apartments, and smart home is installed in apartment by default. I also live in an apartment and use smart home service every day. My favorite smart home service is elevator call because it can reduce the waiting time for the elevator. In addition, it is a useful service to turn off the light and cut off the guests while going out. I use this almost every day too. It is also a useful service to turn on the boiler to make the house warm when leaving the house for a long time. I am very satisfied the smart home service because I can know the home situation anytime, everywhere. The second is Korean smart home standard. Korean home network connection configuration and standard relationship are expressed in a diagram. In the home, each device is connected around the home gateway or wallpad, and each device is connected with RS485 line. The KSX4506 standard is an interworking standard between a wallpad or home gateway and a device. The KSX4501 standard is interworking standard between wallpad and home gateway. However, recently wallpad and home gateway is integrated and released. In addition, there is no need to link with the smart home systems installed by other companies. So we are going to remove the KSX4501 standard. The KSX4505 standard is an interworking standard between the complex server and the wallpad or home gateway. It is also the standard for interworking between complex server and shared unit device or system. The KSX4503 standard defines wallpad function and physical interface specification. The KSX4504 standard defines home gateway function and physical interface specifications. Each standard is organized as shown in the table. The KSX4501 consists of 4 parts and is about interworking protocol among the home network control middleware. Part 1 primer is a guide, and Part 2 base protocol is about the connection protocol between adapter, focusing on the conversion engine. Part 3 data schema defines the format for exchange data, and Part 4 is best practice and implementation guide. The KSX4505 consists of 4 parts and is about the complex server protocol for intelligent home network. Part 1 base protocol defines message structure and type. Part 2 profile for home gateway WordPad define interworking message body between WordPad or home gateway and complex server in the home. Part 3 profile for shared unit in complex network define interworking message body between complex server and shared unit. Part 4 profile for smart device define interworking message body between complex server and mobile phone. KSX4506 consists of 13 parts and is about asynchronous serial communication. In order for multiple devices to communication use a common RS485 line. The home network main unit becomes a master of the communication line and communicate with the individual home network device. Individual home network devices operate as a slave on communication line and can transmit signal only when communication is permitted by a master. Part 1 defines the base structure and each remaining part defines the characteristics of each device. Since Korea uses very cheap RS485 communication method, it is a structure that can supply a home network system at a low cost. As mentioned in the previous page, KSX4503, 4504 define function and physical interface specifications. KSX4501 is a standard that interworking by converting A middleware message into B middleware message, such as animation. This standard has a good concept, but it is very difficult to apply in the field, so it is difficult to use it in industry. In the market, since home network service must be provided stable, it is important to apply them in a simple method rather than applying many technologies. KSX4505 standard is an Ethernet-based communication protocol and define message between complex server and WordPad home gateway, and complex server and shared unit with XML. It is written as needed by the company, but as the number of home network devices increased, the standard is not being followed. Also, some companies apply by converting to JSON according to the last trend. Finally, as shown in the picture, KSX4506 standard defines the protocol between simple device and the master, such as WordPad. RS485 line a method of required request and response binary packet, like a serial protocol. Since the standard was simple, many device companies are applying and selling. Also, home network companies are applying and distributing. The feature is a home network connection structure being considered in Korea. Korea is distributing home network with RS485 device, WellPad, and complex server configuration. Samsung and LG is distributing it by connecting individual devices to the internet and managing them in the cloud. Also, OCF and Meta are expected to supply devices in the near future. Home network companies are also considering interworking with OCF and Meta through a bridge method. Currently, most of the interworking is based on the cloud and is interworking with the construction company. Because Korea has a business structure where a home network is involved when making and selling a house. Third is the issue of smart home standard in Korea. In Korea, there are many issues regarding smart home standards, which can be divided into market perspective and standard perspective. Construction companies always demand new home network services for apartment sales rather than standard one. In addition, home network companies change protocol by prioritizing stabilization and new services rather than keeping standards. There are so many standard issues. Can we solve all the interworking from standard point of view? Standards can solve only the minimum interworking, but many interworking parts are problem to be solved in the market. When a new device is launched, a new standard must be approved, but standard is slow than the market. It is difficult to immediately reflect good feature in existing standards. In Korea, the problem of after service due to the failure of already installed smart home devices is becoming an issue. Early small home network companies went bankrupt because the standards were not followed. The new company cannot proceed with the repairs. Consumers have to replace all systems at high cost. There are many cases in which consumers no longer use smart home services due to high cost. Companies provide inexpensive smart home solutions to solve this problem, but they do not have problem applicable only the place where their solutions are installed. It seems necessary to enforce standards to some extent to that consumers do not feel uncomfortable. WellPad is already installed as an Android-based system that can be linked with new devices. However, since the market went cheap, smart home WellPad hardware specifications are being supplied in a very low state. Therefore, it is difficult to link the consumer current WellPad with a dynamic interworking device. After 2020, the home network market is changing rapidly. AI speaker-based smart home services are growing, centered on telecommunication companies. In addition, cloud-based smart home services are growing as home appliances are directly connected to the internet, mainly from house appliance companies. In addition, the smart home service market using a common protocol was launched. Centered on global top smartphone companies such as Google, Amazon, and Apple. New technologies as market demand new service, and the market is changing accordingly. Global company are forming a consortium through alliance among themselves and linking smart home services in the cloud. Consumer prefer convenient and inexpensive service rather than expensive and good service. Finally, technology has already advanced enough to provide all services, but it seems that we need to create cheap and good service that satisfy consumer. It seems that the standard should be an issue with continuous interest so that consumers do not feel uncomfortable. Thank you for listening to my presentation. Thank you.
Okay, thank you for your good presentation. And I checked the chat box, but there is no questions. So, Hak-jin, are you available to ask some questions? Maybe he's not present. He's not attending this.
Hello?
Hello, Hak-jin there? Okay. Thank you for your good presentation. And you introduced the Korean status of the home network or smart home network activities. So I would like to give you some questions. And the system you introduced is just used the Korean standard, Korean national standard. But there are many other international standards already made. So are there any activities to using the international standard for the smart home service providing? Hak-jin?
Yeah, I am here.
Okay. Did you hear my question?
Yeah.
Okay. So it is very difficult question I gave you. I think because of the wallpad and the home gateway, so that kind of things is very old-fashioned. So maybe if there are some activities using the international standard like METR or OCF, because Korea, they studied very much on OCF, and there are many companies working on that. So I made the questions, but I don't know exactly what is the activities of OCF and METR. So but you may not answer the questions. So maybe Hojin, Dr. Ho-jin, can you explain something about that?
Yeah, can you hear me?
Yeah, I can
Yeah.
hear you.
As you said, the many defects to the protocols are introducing in Korea.
Mhm.
So maybe some industry preparing for the protocols, but in the entry or the government is to see the scope of the Korean industry. So we want our home network to easily integrate with the current defect standard. So it means the open architecture of the smart home, the system. So we are at this time we cannot often the work on the open architecture, but actually is preparing the open architecture to easily accept or integrate with the new smart home product or the protocols. Hopefully, maybe the next year, or we will disclose our specification to the public. Yeah, thank you.
Okay, thank you very much for your good explanation. And I've heard some companies, some energy management companies, they are providing very fancy services using the smartphones for the energy management at home. But I don't think they use the international, well-known international standard for their service provision in Korean energy management at home. So I think in the future, in Korea, they may take a look at the international standard like META or the other OCF or the other protocols for providing their own services at Korea, I believe. Okay, thank you for the presentation and also explanation. Okay, I will move to the second presentation. I think the second speaker is Dr. Chen Bin from IGRS, Intelligent and Resource Sharing Working Group, China. I know that it is the most influential industry standard alliance in China. They are also active in international standardization activities. Dr. Chen has a long time experience in wireless communication, technology, research and standardization. He has big experience in 3GPP, IEEE 802.11 and 15, and CCSA, 1M2M, and the other standard organizations. Currently, he is in charge of technical and standard work at the Secretariat of IGRS. Okay, Dr. Chen, now the floor is yours. Please start with your presentation.
Thank you, Mr. Chairman. Can you see? Okay. Let me see.
Share. Okay.
Okay. Can you see my
computer?
Yes.
It's really good.
Okay. Today I will give the presentation on behalf of Michael. You know, Michael is on leave. He has some family things to handle. So the presentation I gave is titled "The IGRS Progress and Sparkling Alliance." So you can see there are two parts: the IGRS progress report first, and then I will introduce a new wireless communication technology. We term it the SparkLink. Okay. This page shows the history of the IGRS. You know, the IGRS was founded in 2003 by 8 Chinese companies. Like you can see here, it's Lenovo, TCL, Great Wall, Changhong, Skyworks, Hisense, and Concur and Interversion. So basically, they are home appliance company, and they want their product can communicate with each other and interact with each other. So they think we need to build a team to allow this and to build some product. After 2 years of work, this team think, okay, since we can build the product and we may go further to make it a standard, or at least some kind of industry standard. So then 2 years later, in 2005, an IGRS Alliance or Information Industry Association was founded. It was to make a solid industry resource comprise a strong network of member alliance. And also this work was supported by the government. Then you can see here, the IGR State Engineering Lab was established to bridge the R&D and product to increase the acceptance rate of the IGRS technology. So this is a very brief history of IGRS. Today, IGRS has become a member, IGRS Alliance has become a member of over 240s, and IGRS totally is kind of the ecosystem. Is all the IGRS member can produce the module per defined standard and produce product, and also they can have a platform to operate the IGRS product. So you can see here, this is the total a complete industry change. And here is the IGRS, the IGRS standard history of, you can see at least after about nearly 20 years development, IGR has goes through the 3 generations. The first generation is IGRS release 1.0. Basically, it's a kind of a local area network. It has a function like the automatically discovery and connection, and also application interaction function of various intelligence devices in the local area. Then the next generation of IGRS 2.0, it go to the wide area network. Basically, it's go to the internet. Then it's allow the device discovery and service discovery over the internet, and also cover the service and the data collection, storage, analysis, and also allow cross-platform service interaction function. So after the second generation, the third generation of IGRS have a new function of trusted function. Basically, it integrates the mainstream blockchain technology into IGRS standard to increase the security and trust, and also protects data privacy, smart contract, and also establish and improve the security and the trust of IGRS. So that is the history of IGRS standard. Basically, you can see here in the first part, IGRS basically is an application layer standard to support the different kind of connection technology like the Ethernet, 5G, 3G, and Wi-Fi, Bluetooth, and also other physical connection, the physical layer technology. Also, the scope is permission management, automatic discovery and connection, collaboration of application service, message forwarding, and the service platform data processing, like this kind of application. And so this is the standard scope and evolution. Also here is IGR's advantage. You can see here it enables the IoT device intelligence. Sorry, there's some part of the figure is in Chinese. And basically, you can see here, the right part is the 3 advantage of IGRS standard. It has the intelligent grouping, it allows the resource sharing, and also the service collaboration. And as we can see, IGRS, the major work of IGRS is standard. So basically, IGRS has very good standard reputation and a very good experience of standard. So we have developed the enterprise standard, the social standard, and industry standard, national standard, and international standard. You can see here. And the right panel lists the achievement of IGRS Alliance. You can see here in 2012, 7 IGRS standards was in the 3C interoperabilities become the ISO IEC standard. And until now, there are totally 14 standard was published in the ISO IEC. And also IGRS members have actively promoted the development standard to the national standard, the Chinese standard. So, and also there are 7 electronic industry standard has been published by the industry. So that I will not read the whole list. It is pretty long. And here is the IGRS standard in the ISO. The totally, you can see here, there is 14 ISO standard published. And now this page shows the Chinese standard. And okay, no problem. The Chinese standard, totally we have how many? 1, 2, 3, 4, 5, 6, nearly 10. I stopped counting. Okay, and then this page shows that we have a very strong government connection, and when we developing the standard. So this page shows that we have been selected as a social organization standard, a demonstration project from to get the support from the Chinese government, the Minister of Industry and Information Technology for many times. And this page shows that there's only one, maybe, the home electronic system architecture. And this means we have a very good government relationship, and it is very helpful for when we develop the further Chinese standard. And this page shows that the IGRS standard include 2 parts: the module part, the device part, and platform part. And the left part is the IGRS application from the application of a device. And you can see here, it is the application layer, and also includes maybe consumer device, wearable device, and some the industry IoT device, and also maybe the automatic driving device. You can see here the gray area is the IGRS standard. We have a protocol layer. In the protocol layer, the function is, I said before, it includes connection management, privacy, and device and service discovery, something like that. And the lower part is that the IGRS standard is independent of any connection technology. So it has any kind support, any kind of the wireless and wired connection. We doesn't list either of them. So the right part is the IGRS service platform. We have allowed a cloud service platform, and we can enable any kind of the application in the server and in the device and in the website. And also you can see here, we does not depend on any specific connection technology. It also includes NB-IoT, LoRa, Wi-Fi internet, and also here is the sparkling, the red color is next is the new technology I will introduce later. And this one shows the basic, the standard technology element. It includes the protocol, hardware, software, module, and also can be used in the device, IGRS device, and also the IGRS service platform. And this one is the next step of IGRS product development. We hope we can, as you can see before, we say our protocol or IGRS standard is independent of any connection technology. But now there are some very popular wireless connection technology like the Wi-Fi, Bluetooth, and so we think it is better to integrate the IGRS standard into the wireless communication chip. So we will do that, and here is our design or our roadmap to implement it in the Wi-Fi module and also in the NB-IoT module. And also maybe later we can integrate it into the RFID module and also some other things. So this finished my first part, and now I will move to the next part of this new sparkling technology. And here you can see here, IGRS co-founded the Sparkling Alliance in September of 2020. That's almost 2 years ago. The Sparkling is a kind of the new revolutionary short-range wireless communication technology. And basically is we know that the Wi-Fi and the Bluetooth are very popular wireless short-range communication. But with the application of more and more wireless communication in different areas, we found there is some, in some field or some application, Wi-Fi and Bluetooth are very difficult to be used. And then we think maybe there is a new some space for the new technology. So, and we have designed that technology, and we term it Sparkling short-range technology. You can see here, this one is the Sparkling technology, the logo of the Sparkling technology. And here's it is a website. We have the English version of the website, so you can access it, the English version, and to know some of the detailed information. I see here. Okay, maybe I need to share this part. So you can go, maybe after this meeting, you can visit the website. Basically, it's, in the 2 years, we have developed the two technology. We term the first one is Sparkling Basic technology, and also the second one is Sparkling Low Energy technology. The two technology they have the different platform, a different performance. The Sparkling Basic technology is for the application which need very, very low latency and very, very high complex, high reliability of connection. And the Sparkling Low Energy is most focused on the wearable, kind of wearable device, which are powered by the battery, and they have very limited power budget. So they need a very low power consumption for this kind of device. And also, I will give a detailed application of the two technology in maybe the next 3 or 4 pages. This page shows the performance of Sparkling Basic technology, and which we call the SLB. You can see here, that's the SLB technology. It is a very high-end performance, and you can see here, the peak rate, we suppose 800 Mbps per 20 megahertz bandwidth. This is a downlink, and uplink is a half data rate. And also, we can support the maximum data, the bandwidth is 320 megahertz, and with 16 carriers, it is very powerful stream. And particularly, we are focused, the Sparkling technology, we focus on the very short latency over the air interface. So we suppose the minimum latency is 220 microsecond. That is the latency. This latency cannot be achieved by any of the existing short-range wireless communication like Wi-Fi and Bluetooth. And also, you can see here we have the very high reliability, and we allow the synchronization accuracy less than 1 microsecond. It is a very high accuracy. And also, we support the multi-user. The multi-user capability of the SLB technology is 4,096 users. And also, we allow the active user, 820 active users in 1 millisecond. So it is a very big number compared with the existing technology. As you know, maybe they are usually less than 20 something, or even the less than 10 as considered the Bluetooth. And also we have the very good coverage performance than the existing technology. The minimum SINR is -5 dB. And also we have the adjacent channel interference suppression ratio of 70 dB. So it is a very, maybe as I remember, is 5 dB better than the existing technology. And also we support the high security. We support the mutual authentication and algorithm negotiation for the SLB. This one is the performance of the SLB. You just need to remember it's very, very low latency. It's 20 microsecond. And the right part is the performance of sparkling low energy. So in this one, we focus on the mostly is like a wearable device. So the data rate is low compared with the SLB. So, but it's very, very high compared with the any other existing low power wireless technology. So we support the 4.6 Mbps to support the high definition lossless audio, and now maybe for the data communication we support 8 Mbps data. So, and particularly we also focus on the latency of the ear interface. We allow up to 4,000 Hz interactions per second. This is maybe the 10 times, at least 10 times or 20 times compared with any existing wireless technology. We have the reliability of like the 100 minus 110 dBm as receiver sensitivities. And also you can see here we support up to 256 user access. Same as SLB technology, we allow the very high security. We have the mutual authentication and also algorithms in negotiation. And as we say, we are a low energy wireless communication technology. So we assume we design our communication protocol with the concept of the low power consumption. Basically is we allow the interactive voice like the 10 microsecond, 10 milliampere, and audio of less than the 4 milliampere. And so, and also it's the keep alive, the standby power consumption is 0.3 milliampere. It is low power consumption, but basically it's depend on your IC technology. If we have the further advanced technology, maybe it can be further low power. The last 2 pages, I show the performance of a new technology. So this page show is a kind of the introduction of why we do have a new technology. As I said before, every year there's over 20 billion short-range wireless communication chip shipped over the year. Basically, they are the Wi-Fi chip and Bluetooth chip and Zigbee chip, and also other RFID chips. But with more and more application and product, we found there is some application and products they need very low latency for the interaction and very low power consumption, and also they need some a very good QoS guarantee, and also need very high security. These kind of things cannot be guaranteed by any existing wireless communication technology. Is basically we classify the application I mentioned before into 4 categories. They are the smart car, smart home, a smart terminal, and a smart manufacturing. Basically, is because today's meeting is about the home appliance, and the first 3 parts, they cannot be very strictly separate each other. Because like if you have a cell phone, you can make it work in your home, and also have a smart terminal to interact with your collaboration. And also you can bring your smartphone into the car to allow the interaction with the car, with the car device. So I think it is in the scope of this meeting. And here it is a page say why we need a new sparkling technology in the smart car. Here, you can see the left part is there is some until now we have many cable connection in the car. It's the length of all cable in the car may be more than some kind of 4 or 5 kilometers. And also the cable connection have some problem, like it's the very complex, very high price to assemble the cables, and also the kilometer cable have a weight of about maybe 100 kilograms, and also they have some service scalability issues, and also may have some reliability issues. And after maybe a car is 20 years lifetime, and maybe after several years, your connection may be loose, and so the device cannot work. So there is a trend to replace the cable by a wireless communication in the car industry. Here is some application. They need very low latency, like we can see here is active noise reduction or cancellation technology. We need end-to-end delay of less than 100 microseconds. So that is a very short latency. And also we have when you bring your smartphone in the car, you interact the car screen and your smartphone. So you have a in-screen interaction. The latency should be less than 2 milliseconds. And also when you access your car, maybe you need your phone to have a passive entry and passive start. This is also needs some very high accuracy of positioning. And also now we know there is many new energy intelligent car. So they need a battery management system. It's all the existing battery and management system are cable connected, but there is still some, as we say, the left part, there's some more and more reason to replace the cable connect to the wireless connect. So there is then maybe need a wireless technology for the battery management system. This page shows why we need sparkling in the smart car, and also this page shows why we need a smart home, because there's maybe more and more smart device in the home, and the smart speaker, smart TV, and projection, and also smart cameras. And also all these kind of things, there is some interaction between device, not only your smartphone and and your speaker. The interaction maybe needs synchronization accuracy and also the very low latency. Like the latency is the lower the better. Also, there's some more and more application need positioning and perception function in the smart home. And also this one shows some the reason why we need a sparkling in the smart terminal. Like we say here, there is a phone, there's more and more a TWS earphone, and maybe every year's about 2 billion device shipped, but and the user usually have a very high quality requirement on the audio stream. So then all the existing technology are working on to improve their audio quality. And also this one, the real-time mobile game, they need a very, very low latency when you interact with your game. Like here is latency of the end-to-end latency is 20 millisecond. This is end-to-end, so it's very difficult. It includes coding and decoding, and also the wireless transmission. It is also a very high latency, very short latency. It's difficult to be implemented by the existing technology. The right part is a kind of the wireless keyboard and maybe the game console. When you interact the game with the game console, the lower the latency, the better. So that is like when you have a multiplayer game, you punch some guys, and because of the communication latency is about like let's say the 50 millisecond. So within this 50 millisecond, any guy can punch you. So that is a kind of life or death, or life or death decision. Okay, so it is very key requirement for to reduce the latency. You can see here we suppose the update frequency of 4 kHz. So this page shows why we need sparkling in the smart terminal. Also, this page shows it is in the smart manufacturing, like in the industry environment, when we can control some movement of the motor, and we need a very short latency, and also we need a very, very high reliability, like this one is 5.9, maybe 7.9, or even 9.9. So all these I present before in the last 4 pages show the necessary for the new sparkling technology. And as I said before, the IGRS co-found a sparkling alliance to develop the sparkling technology. And this page shows some information about the sparkling alliance. Here is the target. We promote the next generation wireless short-range communication technology innovation and industry ecosystem, and support application in smart car, smart homes, smart terminal, and smart manufacturing. And this part shows the scope of the Sparkling Alliance. And we have the standardization work and test certificate, strategy development, ecosystem construction, application demonstration, external cooperation, and also the information exchange. This one, you can visit our website for the detail of the scope of the work. Now we are mainly work on the standardization part and test part, and also the application demonstration part. And also this one shows the operation framework. As in the dash rectangle, it is a major work of our Sparkling Alliance. And also we have a partner in the cooperative standard organization and cooperative industry alliance, especially in the smart car and smart manufacturing. There are some already existing standard bodies, and we will collaborate with them to support their existing application. And this page shows the organization of Sparkling Alliance. We have from the top to down, we have the board of directory, and we have our supervisionary board. And major work are done by the expert committee and also the secretary. Our IGRS chairman, IGRS chairman is the general secretary of Sparkling Alliance. As I said before, we are a co-founder of this one. And the lower part shows the major working group of the Sparkling Alliance. The major work is done by the standard work is we have the requirement and the standard group. They are mainly work on to define the Sparkling standard, and also the safety group. Safety group is a kind of we say that we have the major application in the smart car and also smart manufacturing. They have a special requirement under functional safety. So this one safety group to have the two major jobs. The first one is the functional safety. Another one is the web security. So it is especially to support the industry requirement. The spectrum group is to see if there are any opportunity or chance to a new spectrum for Sparkling technology. And test and certification group is major work on to ensure the interoperability of our Sparkling device. And here, the right part, we have 4 promotion groups. They are mainly from different kind of industry to adopt the Sparkling technology. And if they have some problem or if they have some requirement, then they will provide the requirement to the standard group, and we make a new standard. So that's this page shows how the Sparkling Alliance work. And also the Sparkling Alliance, we have 2 kind of the IPR policy. We support the front policy, the fair, reasonable, and non-discrimination. It is a very popular one. And also we support the second category of the IPR policy, that is the front RF, the fair, reasonable, and non-description right-free. That means all the IPR contribute to the Sparkling Alliance are free to the other members. So basically is when the member join the Sparkling Alliance, they can choose which type of the IPR policy they adopt. The detailed information you can find here from the Sparkling website. And now this page shows the members of the Sparkling Alliance. We have this Sparkling Alliance in 2 years ago. At that time, the total member is 19. Now, after 2 years, we have a member of 257 update. So you can see this part shows the different the members, the different category of the member. Like if you are a car maker, maybe you belongs to this one, the red one. And also, if you are kind of the application developer or cloud service, you belongs to this one. Its manufacturing is this one. So we cover the total industry chain, include the industry organization, university, academic institute, chipset manufacturer, and the module manufacturer, car OEM, car service, car tier 1, tier 2, providers and smart device manufacturer. And also we have test instrument manufacturer, application develop, and also some of the mobile device and mobile operator. And you know, just 1 month ago, we have Sparkling Summit 2022 in Shenzhen. In the summit, we have we have 6 demonstrations. As you can, I said before, one of the job of the Sparkling Alliance is to demo our technology. And after we have the standard, we need to show the standard will work and can be implemented. So this page shows two demonstrations from the summit. The first one is all around the surround view. It's kind of the, you know, for a commercial vehicle like this one is the truck, and the truck have a trailer. It's a very long, maybe nearly 20 meters long, and it's have a very large area where the driver cannot see the surround area. So we need some of the camera to help the driver to see all the surrounding environment, the condition. And here we show in this demo, we show that our Sparkling connection can support 1 to 6 up to 6 video camera. And then we have this one, the OBU onboard unit. They can synchronize the 6 different image into one total, one whole view or surround view image in in this part to allow the driver to see what happened in the surround. And this one, the surround view system is defined by a mandatory features by the Chinese government for the commercial vehicle. And so the technology difficult for the surround view system need very high throughput. At least the capacity need to support up to 8 video stream, and also they need a very high accuracy of synchronization among the video cameras. The synchronization is 1 microsecond. We have when we show the demonstration with the Sparkling technology, the company have also tried to use the Wi-Fi to implement the surround views function, but it's very difficult and very poor quality. So this is one. The second one is also in the car, or it is a immersive lighting. So it's here, you can see the figure. As the immersive lighting is kind of the, you know, the light effect when you share in the ball or in the party. You know, especially the young people like it very much. And when they dance or drink something, but the difficult things here is in order to implement the very good effect for the whole environment, you need to synchronize your light, your audio, or maybe sometimes your video, and all these devices need to work together, and the device number is pretty high. Like nearly, you need to support maybe 100. So, and also it's need the synchronization among this device. It should be very, very high accuracy. And these are the kind of the technology difficult. And this one is show the wireless projection. We support the 4K resolution, high resolution wireless projection, and it's very popular in use in the mobile phone. And the right part is we support the 7.1 channel sound. You know, the channel sound is kind of the very high quality audio system. and it's need to support the very high quality of the audio quality, and up to at least 7 devices to synchronize each other. So this one is synchronization accuracy on all. This one, we showed also the active noise cancellation system in the car. As you can see, more and more people like a very quiet car. When they drive a car in the, there is some noise, and the active noise cancellation is kind of light technology to reduce the noise. Basically, the difficult to achieve the wireless communication is you have to make sure the latency is very, very low. Like when you have a microphone to sample the noise, and you have the data processing, and you have inverse phase noise to cancellate the sampled noise, the total end-to-end latency must be within 100 microseconds. So you need very, very low latency for this one. And the last one is we need a low latency for the industry, a manufacturer. When you control synchronization motion control, you need a low latency, like 20 microsecond or 10 microsecond. And also you need very, very high reliability for this one. And this one is the last page you need to, I hope you can remember, is we have a new short-range wireless communication technology, SmartLink. It is a cutting-edge technology for smart car, smart terminals, smart homes, and smart manufacturing. And all the first parts, I talked, the IGR standard can be used on the top of the SmartLink Air interface. And here you can see it is a member wall when we have the SmartLink panel. And also you need to remember is we have a SmartLink a chip, the wireless communication chip support maybe in the next year. I hope it can be in the first half years of 2023. And also we hope there may be up to 16 SmartLink product in the next years. And also you can see here, you can visit the detailed information from the website. And also we have some the connect information for our SmartLink technology. Thank you very much.
Okay, thank you, Dr. Chen. And I think your presentation is very interesting, especially the SmartLink is the very new information you gave us, and it's very helpful for us. And there are some questions. I think there is, okay, the SmartLink, the participant is already 250, but I believe all the participants are Chinese organizations. And do you like to make some international standards afterwards? And if any, then what kind of standard bodies you are focusing on?
Yeah, I think that's a very good question. As I say, now we have 247 members. Most of them are Chinese company, but there's still some international company. Maybe there's a Chinese branch. The members, they join the SmartLink Alliance. And currently we have worked on the standard, and also, as I say, that we have defined the two air interface technology. And we hope to make it a international standard is one job we are working on, but there is some there's some still procedure we need to go from maybe the government or the industry, and we work on to make it a kind of the international standard.
Mm-hmm. Okay.
Yeah, and also it is open to any company.
Okay, thank you. So we may join the Spark link afterwards.
Yes, they can join. And also, as I told you, is we translate all our Spark link standard into English.
Okay.
I hope it can be done in next 2 or 3 months.
Okay, you'll see soon. Thank you very much. And also, one more question is the range. How short range is 10 meter or something?
Basically, is when we say the short range is, we have the common definition of the wireless short range concept. Okay. The detailed range is depending on the the communication environment. For example, if you are in the free space, in the outdoor, this distance may be reach 100 meters, but for the office indoor case, typically is less than 10 meters or 20 meters, something like that. And, but I think we have better coverage than any existing wireless communication technology because we use some advanced codec, like the new one you defined in the 3GPP or in the 5G system, and that's our secret weapon, I think.
Okay.
That's open. That's open standard.
I believe so.
And open technology.
Okay. And it's not a question, but I have some suggestions. The short range, even the latency, the delay is very short. It's less than 20 microseconds. Then maybe we can apply that technologies into the medical systems, smart medical systems. But you don't have any working groups in your alliance, so I suggest.
Okay, thank you very much.
Okay.
Yes,
you may open for the smart medicine. Okay, thank you very much for your good presentation and informative informations. Thank you very much. And I'd like to move on to the third presentations. I'll introduce the third speakers. It's Yoichi Masuda. He's a system architecture working leader of the technical committee of the ECONET Consortium. He's working for Panasonic Corporation for almost 20 years. And from 2013, he has been leading the ECONET Technical Working Group. I think he will introduce the ECONET Light Protocol, known as a standard interface for the home energy management system, which was recommended by the Japanese government in 2011. He will also introduce the web API to link Ethernet light devices in the cloud and the ECONET 2.0 vision announced in 2018 and its future direction. Mr. Yoichi, welcome, and please start your presentation.
Thank you for your introduction. Good afternoon, everyone. I am Masuda from ECONET Consortium of Japan. Let me share my screen.
Yeah.
Can you see my screen?
Yeah, I see well.
It's good. Thank you also for the opportunity to speak today. I'll be speaking on the title of Status of Japan's Smart Home Standard and Use Case. This is today's topics. My presentation is divided into 3 parts. At first, I will give an overview of the ECONET Light standard. And secondly, I will give an overview of the ECONET Light Web API. Finally, I will speak about the world that ECONET 2.0 is aiming for. So I will start with talking about overview of ECONET Light. Before introducing ECONET Light, I would like to introduce the ECONET Consortium. ECONET Consortium is an organization that promotes communication protocol Econet Lite. Our consortium founded in 1997. We released the Econet Lite standard version 1.00 in 2011, which is a lighter version of the conventional Econet standard. Econet Lite protocol is for home appliances and housing facilities, which are essential elements of smart homes to cooperate with each other. And we have announced our Econet 2.0 vision for user expansion in 2018. In addition, the composition of the consortium's member is 6 managing members and 164 general members, such as home appliances, electric power, gas, telecommunications, and so on. And 39 general associated members, such as universities and research institutes. Econet Lite is a communication specification for sensors, appliances, and devices with low computing power. Econet Lite helps to develop various services by connecting various devices, and target applications of Econet Lite are energy management or healthcare and so on. Our consortium helps anyone to provide these services. This slide shows an architecture example of home network. Econet Lite controller and devices are installed in the home. And the Econet Lite controller is connected to a server on the internet. So the server can control devices and store devices data via controller. For example, when the controller receives a demand response signal, the controller controls devices in accordance with the signal. And various services, such as energy management, are realized by linking with the server and utilizing the data. Here, the scope of the Econet Lite protocol is the communication interface between the controller and the devices in the home. In the previous explanation, it was an example of use at home, but the target fields of Econet Lite are assumed to be apartments, stores, and small and medium-sized buildings in addition to homes. Econet Lite standards correspond to layer 5 to layer 7 of the OSI reference model. The standard consists of 3 parts: communication middleware, control commands, and application communication specifications. First is the Econet Lite specifications correspond to communication middleware. And this is certified as an international standard as ISO IEC 14543-4-3. And second is the detailed requirements for Econet device object, which is corresponding to the control commands. It's also an international standard as IEC 62394. In addition, we have developed the application communication interface specifications for each device to define detailed communication between the device and controller in order to realize each application. And we are also promoting international standardization of these specifications. So far, an international standard has been published for home air conditioners as ISO IEC 14543-4-301. In addition, a proposal for storage battery is currently underway, and proposal for key devices will continue to be made in the future. And from this slide, I will speak about the main features of Econet Write. Econet Write defines commands and protocols, but does not define transmission media, which are transportation layer, network layer, data link layer, and physical layer. And therefore, it is possible to select a reasonable transmission media source from the market based on various requirements such as services and applications. For example, Ethernet or Wi-Fi and so on. In Econet Write, the IP address or MAC address of the transmission media is used for the communication address to identify the other party. In addition, multicast address and port numbers to be used are also specified for the lower layers. Econet Consortium defines device object by modeling various programs and the data that various devices have. For example, a device object for an air conditioner is an air conditioner object. The air conditioner object has various properties such as operating status property and operating mode property. When operating the air conditioner, the values of these properties are set. When you want to monitor the status of the air conditioner, you can refer to the value of this property or receive notification of the property value. In Econet Write, properties are used to control devices in this way. The definition of these device objects are also expressed as control commands. We have continuously expanded the control commands since the establishment of the Econet Consortium. The latest release queue of control commands covers 118 models of device. The support for the control of a large number of devices is a feature of Econet Write. In addition, various properties are defined for each device object, enabling detailed control. We have defined detailed control commands for 118 devices type so far, including sensors, energy-saving devices such as air conditioners and lighting, and energy storing devices such as storage batteries and heat pump water heaters, or energy generating devices such as solar power generators and fuel cells. Measurement devices such as smart meters. Note that the device objects are classified into 7 class groups according to their use. Our consortium has defined the devices as key devices, including home air conditioners, storage batteries, solar power generation, and smart meters. The key devices are blue letter device in this slide. In order to achieve a higher level of interoperability for these devices, our consortium has released the application communication interface specifications. We call them AIL specifications. They define the specific usage of Econet Write at the application level of each device. For example, they define timeout after sending a request until receiving a response, or sequence assuming concrete use case, and so on. And it is important to study overall system architecture, to study communication specifications. When we formulated the Ethernet rights specifications, we designed an architecture which set controllers or similar devices which have gateway functions between various internet-based services and devices installed at local environments such as ordinary homes. This slide shows an example system configuration. This system can be built using Ethernet right. Specification study and development in services and devices can be done respectively and parallelly. Therefore, this enables us to expect services to be provided not only by device manufacturers, but also by various service providers. The Ethernet Consortium has established a certification system to certify that products correctly comply with the Ethernet rights standard and Ethernet right AI specifications, so that users can build home networks with confidence. Certification can be obtained by passing certification tests conducted by a third-party organization authorized by Ethernet Consortium. The graph here shows the cumulative number of Ethernet rights standard conformity certifications obtained. As shown in the graph, the cumulative number of certified products has been steadily increasing and now exceeds 900 models. We are also organizing progress to further improve Ethernet right interoperability. And this graph shows the shipment quantity of Ethernet right compliant products, including smart meters from fiscal year 2013 to 2021. The cumulative number of Ethernet right devices, excluding smart meters shipped from 2013 to 2021 reached 51 million units. The majority of these units were home air conditioners, followed by water heaters and storage batteries, and so on. On the other hand, the cumulative number of installed smart meters by 2020 and planned smart meters to be installed in 2021 reached 75 million units. Therefore, the total number of Ethernet right compliant products by 2021 has reached more than 126 million units already. In this slide, I will speak about use cases with using Ethernet right devices. The first use case is time-bound tariffs. By applying Ethernet right between smart meters and home energy management system HEMS, the HEMS can acquire the amount of electricity used from smart meters. Furthermore, the HEMS can control air conditioners and other equipment, thereby reducing electricity costs through optimized control corresponding to the time-bound tariffs. The second use case is for in emergencies. Even in the event of a power outage, HEMS will automatically control TVs, refrigerators, and other appliances once the storage batteries have begun discharging, so we will have peace of mind. The third use case is for when you are out. Before returning home, the HEMS can control the cloud from a smartphone to run the air conditioner to make the room comfortable after returning home, or by instructing the water heater to fill the bathtub with hot water. You can take a bath immediately after returning home. The first use case is for waking up. Before waking up, HEMS can automatically control the air conditioner and open the blind to brighten the room for comfortable awakening. The final use case is for going out. By pressing a single button on your smart home, when you leave the home, you can close all windows and turn off all lights at once. As in these use cases, controlling home appliances using Ethernet Light enable energy saving and comfortable living. Secondly, I will give an overview of the Ethernet Light Web API. Along with the improvement of IoT technology, the service provision model via the cloud environment is progressing. Within this model, new collaborative services and applications are emerging, such as providing Ethernet Light compatible devices to service providers via the cloud, and various business developments are expected. Therefore, we have developed a system construction and application implementation guideline using the Web API for operating Ethernet Light compatible devices. We aim to promote the future expansion and popularization of Ethernet Light and its application fields by publishing and utilizing it as a reference guideline. Various services providers can access their Ethernet Light Web API compatible cloud in a unified style. Through the cloud, it becomes possible to operate and monitor IoT devices placed in the user's home. Note that an Ethernet Light Web API is intended only for the Web API that the server presents to the client and does not cover the communication section between the server and the home. This section is vendor specific. The Ethernet Light Web API document summarizes reference design guidelines for Web API models and JSON models for device objects, mainly targeting use cases in which basic operations to in-home devices performed using Ethernet Light are realized via the cloud. Ethernet Light Web API documents consist of API specification part and device description part. And specifically, API specification part organizes the basic policy for Ethernet Light Web API models and guideline for mapping Ethernet Light specification to Web APIs. Device description part specifies device descriptions for device objects such as air conditioner, smart meters. And device descriptions are data type and property resource specifications and are written in the general JavaScript object notation and JSON format. This makes it machine readable specification. Target devices are added as needed, and the device description are being updated. We are also considering a flexible model that can be used to operate not only Ethernet Light devices, but also various other devices by referencing these web APIs. I will explain the basic operations supported by Ethernet Light Web API. The basic operations of Ethernet Light are mapped, getting device status, and controlling and monitoring device status, and notification of device status. For getting the status, the data cached in the server is returned to the client in some cases, taking into account the response delay to the home device. For notifications, it is assumed that caches such as notification status changes that occurs in devices will be communicated to client via the server as immediately as possible. This web API also supports operation to obtain a list of devices. There may be cases where a list of all devices in a device user's home is obtained, or cases where a list of devices obtained by specifying the model, such as air conditioners only. So I will skip this slide. We provide a web API experimental cloud for consortium members. This web API experimental cloud conforms to the latest web API specifications and device descriptions. The purpose is to support understanding of the specifications of the guideline and to verify the operation of each web API. Since we provide device emulators on the cloud, there is no need to prepare actual Ethernet write compliant devices or controllers. The cloud provides device emulators for a total of 38 different models. Device emulator in the cloud can be added and deleted using a specially prepared web API for configuration. It is also possible to change the values of properties for which the set function is not defined and build a unique system configuration. So users can use this experimental cloud to confirm the operation of device operation requests and responses using the Ethernet write web API. And finally, I will speak about the work that Ethernet 2.0 is aiming for. And nowadays, various services are increasing in the virtual space on the cloud, and it has become the age that is aiming to realize a super smart society by cyber-physical system. As the internet environment and society itself change drastically, our consortium set up the Ethernet 2.0 strategic visions, and our consortium strengthened the cooperation with related organizations, along with expanding the Ethernet write. Ethernet 2.0 aims to contribute to SDGs by creating a wide variety of new services through the development of Ethernet write-based platforms by expanding the way services are linked in the cloud era. Ethernet 2.0 has expansions in two directions. The first is to expand and enhance the Ethernet write standard to fields other than home appliances and housing equipment, because Ethernet write has become widespread in homes and lifestyles already. The second is to expand services and service cooperation on the cloud and to create new values by creating new services to respond to the spread of IoT houses, IoT stores, and IoT offices. And this slide shows an example of collaboration with other organizations. We think each standard was brushed up within the industry as a result of years of optimization efforts, and silo boundaries exist between each standard. So we think connecting these optimized silos can create new value and services. The ECONET Consortium is promoting accelerated collaboration between organizations for co-creation and has first established collaboration guidelines with PCHA for this year. PCHA is short for the Personal Connected Health Alliance, and it is an international standardization body for health and medical care. Our consortium also established collaboration guidelines with the CHAdeMO Association, which promotes international standards for electric vehicle charging and discharging devices. In this slide, I will now speak about specific example of data linkage between ECONET-Lite devices and healthcare devices. Service provider uses ECONET-Lite Web API to link. Data linkage is defined as enabling service providers to acquire data from home appliances, home equipment, and healthcare data for the elderly. I will explain the flow of healthcare data being provided to the service provider's cloud. Let's then take measurement using thermometers, scales in their homes. The measured data conforms to the continuous standard and is captured on a smartphone via Bluetooth. The smartphone is connected to the individuals, and the measured data is stored on the FHIR server as the individual's healthcare data. The data stored in the FHIR server is the target of the linkage. For example, if healthcare data is requested via ECONET-Lite Web API from the server and service provider's cloud to the device management cloud, the measurement data is obtained by specifying the individual ID and measurement data code via converted Web API for the FHIR server. And the Japan Advanced Institute of Science and Technology, JAST, is currently building a prototype of this system. In order to realize service cooperation to create new value, it is necessary to cooperate with services on the cloud, including not only ECONET-Lite devices in the home, but also various IoT devices. The ECONET Consortium realized this cooperation by providing ECONET-Lite Web API and aims for smooth service cooperation in cyberspace. For that reason, the cyberspace where cooperation with services is developed must be an orderly collaborative creation space. Our consortium will tackle such issues in cyberspace and contribute to the creation of an orderly collaborative creation space. This figure shows the component of an orderly collaborative space in cyberspace. With the API server on the right and Web API client on the left, the Web API server defines the functions that can be provided by modeling the functions of the device in cyberspace for a wide range of equipment, and such as home appliances and housing equipment, and so on. The Web API client defines services provided to homes, lifestyles, and society through cyberspace, such as energy management, comfortable living support, healthcare, and so on. The names of Web API server and Web API client are new names that expect equipment vendors and service providers to play roles that go beyond conventional fields. By connecting both the ECONET Web API server and the Web API client via common interface called Web API, a stronger cooperative relationship will be built, and that it will contribute to the realization of SDGs. That is all for my presentation. Thank you so much for your attention.
Okay, thank you very much, Chief Masuda. I think I'm sure that we got a very deep understanding of ECONET through your well-prepared material and presentation. And if there's any questions, then just write on at the chat box. Then I'll give him. And personally, I have one question. You just mentioned about the architecture at home with the ECONET controller and the ECONET compliant devices. It may be something like connected devices, but do you also define some wireless communication methodology at home between controller and devices?
Yes, of course.
Mm-hmm.
ECONET Lite using Wi-Fi or Wi-SAN.
Okay. And also, usually we use the gateway for your controller, but you use controller. What's the reason? Any special reason for that? Usually, the devices you mentioned is like a gateway, we call it, but you use controller instead of gateway. So that's why I'm asking. Maybe you have some control functions inside in the gateway, so you named the devices as a controller, maybe.
Controller have controller can know the all status of devices. So controllers can control optimized control.
Okay, I think your devices, your controller is maybe has more functions than the gateway. I simply understand like that. So, okay, thank you very much. And there is one more question. In terms of data ethics, especially for healthcare, how are you securing the data pipeline, especially when we think about consent for purpose of use of personal data? So you are mentioning about the healthcare services, like smart healthcare services. In the case, we need to handle the personal data very carefully. So is there any special way to provide that kind of security or private functions in ECONET architecture? That is the question, I think.
The security is a matter for future consideration.
Okay. So I think it is very careful to use it right now for the smart healthcare services, I believe, because it's very keen for the privacy. So I believe you can prepare also that kind of functionalities in your ECONET architecture, I believe. Okay, thank you again, Masuda.
Yeah, thank you so much.
I think we successfully finished it, the session 3. And now we will continue to the panel discussion sessions. So I think we are going to start directly. Okay. Thank you, all speakers and participants, for your strong interest on today's topic. And I hope you will continuously stay the panel session until the end and get to exchange good opinions for smart home and smart city furthermore. And all the speakers are joining this panel, and Dr. Masato Nagasawa, he's joining into this panel too. Dr. Masato is a chairman of the promotion committee of the AirConnect Consortium. He is working for Mitsubishi Electronic Corporation. In recent years, IoT technology has been used in our daily lives, creating various services and becoming a convenient and efficient smart society. But we know that the technological complexity is increasing. Simply, this has led us to face a number of problems. Among them, the interoperability of various devices and systems using IoT technology is considered the most difficult problem to solve. Home is the starting point for our everyday, and at the same time, home is the starting point of the smart city. Because of this, home, especially IoT technology-driven smart home, becomes important and essential for making a starting point to solve this complexity mentioned as today's agenda. Standards are the key to solve this problem. Many countries and companies are aware of this problem and are preparing various standards. But a lot of home appliances are made by a lot of vendors, so they follow a lot of standards. Therefore, rather than considering the superiority of these standards, we should recognize its characteristic and consider how to link them and how to integrate them together. So I'm going to proceed with the panel from this perspective today. Okay, we will cover 3 topics in this panel session. I think before that, I recognized a question on the OCF that was following. If OCF is providing any interoperability with other existing standards, such as KNX, ECONET, IGRS, are there any examples? That is the question. Can you answer, Mr. Brian?
Yes. So OCF is agnostic, and we are trying to work alongside other standard bodies to create that bridging capability. So we have a number of businesses now working towards, that sort of interoperability with other standards. Right now, and why I asked the question about healthcare, one of the projects that we're doing in the UK now is to think about how we create security from the device to the edge, to the cloud, and then to a GP or a clinician. And it would be useful to think about how we could work with EcoNet, with KNX in those areas, so that the data itself is not just secured, but also how we provide, governance around the usage of that particular piece of data. So I think, one of the key areas on this is who is the data controller? And, if it's the patient, how the patient then provides that consent for purpose for the use of their medical data. So again, these are the things that we're looking to work with other standard bodies around.
Yeah, and I have a further comment. So OCF has done a lot of work on interoperability with other standards, and there are articles and white papers available of how we've done this. So I'm sharing a link to one particular example of OCF core device framework working with BACnet.
Okay. Okay, it's on the chat box. Okay, thank you very much for your information. Okay, anybody has some questions, then just look at the link and then get much ideas on that. Thank you very much. And then for the meta presentation, are there any questions? If any, I will handle first. If you have any, please leave it at the chat box. Okay, no questions for meta. Okay, I will now move on the main agenda. The first topic is what is the adoption of home network standards in each countries and industry sectors. For Korean case, Kash, can you have any information on this topic? Who can answer this question? Kash. Mr. Byung-hun, can you answer this question?
Actually,
okay.
Yes, I just joined this meeting as an operator on the step today, but okay, okay, as speaking as one of the local member in field of smart home and home network industry. Now the one of our member, the speaker, as he said, we are still on the issue of how can we solve the connectivity at in the local network. Well, today I very surprised to for the local home network system, the running by the IGRS and the Econet. We didn't meet for 5 years for many issues. At the time, I remember we were staying on the local network and how can we solve the connectivity, the issues. But after the 5 years, it is very different. In China, IGRS is focusing on the interconnectivity between the domains, the home and car and home and other domains. Broadly, the standardization is the making now, and in Japan. Also, I impressed so much about the certified product. The certified product is very increasing, and now they are focusing on staying on the cloud level, not the local level now. So and additionally, all of the home network is considering the services not only for the networking.
Okay.
So in Korea, we have some of the problems still. How can we solve the local site networking problems? The providers like in the construction companies and home network system companies among us. So I hope still I know it's not it's adopted in our local side in the industry where because it's not enforced yet, but after solved these connectivity issues, maybe we can also have to consider about the user services as well as the national the defector standard also. So maybe I hope we can improve the connectivity in our country also.
Yeah, I believe so. In the future we can do that.
Yeah.
And I think we need also some kind of associations like ECONET or IGRS. So Kashi is a very big, has very big responsibility for that. So just make an effort on that. Thank you very much, Byung-hun. And next, the ECONET, any information can you provide for us? Maybe Dr. Masato Nagasawa, can you tell us about this topic?
Yeah. Thank you.
You have some echo. Yes, ECONET. Okay.
Thank you, Chair. I can speak the presentation.
Okay, do you prepare? Okay, you have some presentation. Okay.
Just the documentation.
Or just simply present your presentation. Okay.
Hi. My name is Nagasawa from ECONET Consortium. I will explain the documentation. This indicates the growth of the zero energy house market. The Japanese government is working on various policies to promote zero energy house, which offers affordable and comfortable living. In 2020, about 56% custom-built detached house built by house builders with zero energy house. In order to have advanced energy management, such as home energy management system, is required to manage and control the creation and consumption of energy. ECONET Lite is officially recommended as the communication standard for home energy management system. And next, as Masuda already explained, in Japan, the ECONET standard is being installed in equipment to save energy in homes and facilities. And it is said that by 2021, there will be more than 120 million units. This is the current status. And the next is I'd like to explain the new standardization actions. So ECONET Consortium announced the ECONET 2.0 vision in 2018 and strategic guidelines in 2022 to accelerate the transition to the web. To this end, the ECONET Web API has been developed and is currently being refined. And in 2021, two market introductions using this Web API were launched. Remote control service and energy management service. So next, this year, ECONET Consortium has established the new strategic goals in market. Here we have set not only the existing strategic goals within the edge, but also new goals on the web. In particular, the target is to establish 50 ECONET Lite web API services. And we expect new services to spread through cloud interconnection. This is a brief introduction.
Okay. Thank you very much for your fruitful information. Okay, I would like to invite the IGRS. Do you have any ideas and information about the application of this smart home?
Regarding the application in the smart home, as you can see in my, let me see.
Presentation.
Yes, we have. Okay. Yeah, wait, let me show the slide. Yes. Here you can see the smart speaker. You have a very high quality sound system. You have one speaker, one source, a player, maybe, and you have maybe several, maybe up to 8 speakers. As we show in the demo, 2.1 channel sound system that are up to 8 sound system. This is one for the high quality, very high quality audio system. And in this one, you can see the wireless projections from your smartphone to the television. And we support the very high definition of the video system, the 4K 8. And now we show the demo is a 4K high definition video. And I think maybe next year we will move to the 8K high definition videos. And the third one is the smart camera, or you have the monitor system, and maybe you have more than one monitor camera if you have a big house, especially maybe in the US or in the Europe, and also maybe in the countryside of the rural area, countryside, you have a very big house and you need multiple video camera to monitor if there are any intruder or anything happened in your home. So this is one. Another one is like positioning and perception. This is particular interest application when we start our Sparklink Alliance. And there's one company, they say they like to monitor the old people when they do the health care for the old person, because maybe the top reason for the old people is they fell on the ground and no one knows. Especially maybe I heard some news in Japan and also maybe in Korea, some of the old people, they live alone. There's no family member live with them for some reason, I don't know. And also maybe this is in China in the next few years, maybe this is also the same situation. So we need perception, the perception function for this one to detect if the old people is found on the ground for a long time, and if they can move, or if they just normally walking in the room or sitting in the chair a long time. So this is a kind of new function, and also think the Sparklink is working on this direction to allow the perception functioning as long as with the communication function. Yes.
And how about the situation of the home electronic systems? The companies or industry sectors, they are adopting your IGRS standards on their systems or devices.
Yeah. Oh, I think the reason I list these 4 applications in my presentation is we think there is some problem for the traditional wireless communication technology to be used in these 4 scenarios. For any other ones, I think maybe all the existing technology can do this application pretty well. So that's why I do not list them. But it do not means we don't support this kind of application. Just as I said, any existing application, they can be used on all the, like we say, the Econet, the web API. They can just build on the new air interface.
Okay.
That's no problem. Yeah.
Okay, thank you very much. And at the chat box, someone asking about the HCA, and there is some answer about that. So just refer to that. And also, I think I'll move to topic 2. In case of de facto standards, according to the business strategies, smart home market, especially SMEs, have been confusing. Are there any possibilities which, if standards are able to cooperate each other or integrate for fully connected home services in future? I will invite Silicon Labs, the protocol Matter. Rob Alexander, can you give us your opinion?
Hello?
Yeah.
Hello? Rob,
Sky Liu?
Yeah, Sky. Yes.
Okay. So you can answer that?
Yeah. Yes, for the, this is Sky Liu from the Silicon Lab, from the China team. So actually, we are leading Matter solution provider in the market. So we already have more than 20 years support smart home applications. For the Matter, I think that's it's a great opportunity to bring smart home industry opportunity to work together. I think the main force is the ecosystem. We see the 3 top company, Amazon, Google, SmartThing. These guys is join this alliance to drive the common standard for the smart home industry. That's a painful in past 20 years because interoperability, security, and a different protocol, different wireless. So I think the Matter is bringing the new opportunity for the industry. Of course, this is a new standard. With a new standard released to the market, definitely is not perfect. Also have some issues like just the Q&A that asked about the Matter 1.0 version have some issues like it's not well supported the low power device currently. But I think that the CSA Alliance are already attention about these issues is working on the fix the issues. And another thing I think the Matter is currently, Matter is over 250 companies join this working group to drive the new application, new device, and fix the bugs. Also have some new data model to support the use case. I mean, in real smart homes. That's I think it's a strong life for the industry because here is a ecosystem, here is a retailer, here is a chip vendors, also here is a lot of the device makers join this ecosystem. That's called the Matter. This standard is a ecosystem to help have a very strong life for the industry. So as a CSM Alliance, their plan, they already planned that next year, maybe first half of the year, is a new device like a home appliance will be supported better. So the second half of the year, the gateway will be supported, will be improved the support of the device. Of course, in next year will be 1.1 version released to the market. I think that so many companies contributing their experience and the technology to make the Matter to better. Okay.
Okay, thank you very much. And personally, I would like to ask one thing. The smart home or home electronics, there are very large companies like home electronic systems like Samsung and LG and other foreign country companies. So do you believe they adopt the Matter protocols afterwards in the future?
Yes, actually in the CSM Matter working group, there are a lot of the sub working group. One of the sub working group is home appliance. Talking we traditional we call the white goods. It's a home appliance like a washing machine or cooker like this. So here is I think is the Samsung and the Hisense, these traditional home appliance makers already contribution is their experience data model, try to push out the home appliance support better and quickly as they can. Yeah. Okay. So definitely, maybe this leading home appliances, they still have their own protocol, but I think it's the technology, the market and the technology also move forward. So we can see currently still a very good trend for the CAC. Yeah. Okay. We see. Okay, I'd like to hear from HCA President Yuno Che. Please talk about this topic.
Sorry, can you hear me now?
Yeah, I hear it.
Okay. So I think today was a learning experience for me. I think number one, because I myself am kind of a beginner to the standards world. Mm-hmm. And, you know, so I come from a business background, right? So my, you know, primary job is to basically make business deals happen. Mm-hmm. So, and I think one of the reasons why, you know, our CEO has asked me to you know, lead the HCA initiative from Samsung, and why the HCA members allow me to, you know, serve them and to run this is because I think I approach this a little bit differently, and I can provide my perspective, and it may not be, I think, you know, the same as a standard perspective, but my perspective is this, right? So that there has never been a lack of good technology, or there has never been a lack of smart people, right? I mean, look at this audience we have here today, right? So we have, you know, the smartest people in the industry in this Zoom call here. But I think the challenge is to understand that we are all businesses, right? Whether, you know, it's a country, whether it's a region, whether it's a company, there is the competing nature of all of this, right? And so, you know, first of all, recognizing that, and there's a common ground, right? And the common ground is what will benefit the companies, what will benefit, you know, and more importantly, the consumers, right? I think to me, the focus of many of this should be, you know, what is the actual sort of benefit it leads to, right? We've spoken about a lot of use cases, and it's all excellent use cases, but the adoption is always the challenge, I think, you know? And so for me, I think it's starting with a common ground, even if it's a small common ground, starting with a common ground that we can agree on. And then if it succeeds, if we are able to actually interoperate, right? We're not trying to interoperate, you know, a giant amount of devices and giant amount of capabilities all at once. The approach I would like to, you know, recommend and bring maybe to this table is to say, you know, there's a small set of, you know, agreements that it's easy for us to make. It is non-threatening, and once we make this, and once we deploy, and once the people, you know, consumers actually feel the benefit of that, there's a natural sort of growth, right? So to me, I think I am more about market growth and actually testing it in the real market. To me, I think this is the right approach, right? So whether it's OCF or it's Matter or any of the other standards, right? And you know, energy management standards, I think the approach that the HCA board, you know, talks about is, well, you know, if we need to develop something separate, there needs to be a very, very good reason, because it's intense in terms of effort. It's intense in terms of building momentum, right? So if there's a a great sort of standard or metric or regulation out there, we should work with them, right? Because in the end, I think the HCA membership is primarily made up of the members themselves driving it. So for us, creating the standard is not the goal, right? Our goal is to actually get it into adoption. And then eventually, my best case scenario, I always say this is, if we succeed, right? HCA should go away, right? HCA should start, existing. That would mean the success has actually happened, because we would have, adopted this and the industry would have, moved forward, right? So I know that's a very general statement, but I think it's something that, look, think of it this way. 1 year ago, before I was involved with HCA, I have actually never really taken a hard look at standards. When I looked at standards, so when I got the job and basically had to, to do it, what I did was I looked at the past 5 years of standards, right? And then just did a simple business analysis of why didn't it not work, right? Why was it not successful, right? And I think, there are some very common symptoms. So I think that's the approach. So we remain open to that. And I think, Matter, OCF, all of this, we are cheering for it and we want it to succeed, right? And we will support it. But I think the approach needs to be more pragmatic, right? So.
Okay, I fully agree with your business strategies, and I hope the HCA will get some leadership of this kind of activities. Thank you very much, President Yoon. And next, I will invite OCF Brian for this. Do you have any good information on this? Any efforts?
Yes, and again, I concur with what has just been said. OCF have been working extremely hard in this area over the last 12 months. Our focus has been the development of collaborative partnerships with other standards bodies. And more importantly, I think one of the key things that we need to develop here is root of trust. For any consumer or for any commercial entity to adopt any type of standard or any type of application, they need to trust that device and they need to trust that the data that is being delivered by that device is being used appropriately. So I think, there is a common ground here that we can all work towards. And I know it's certainly OCF's strategic plan to develop a global smart city marketplace, whether that's for smart home or smart commercial, but more importantly for city leaders who lack the capability and capacity to really fully understand the technical challenges. The most important thing for them is to have a brand of trust. And that can only be delivered by working collaboratively together to develop this. And I think that's where the direction we are moving towards. And I would welcome further conversations and the creation of a forum to, provide that going forward. So yes, we have numerous examples of where this is going, and in doing so, that allows interoperability to become more efficient. The federation of data through the use of data commons and the creation of digital twins, that really then will be the foundational building blocks for any smart city, because that's the failure of smart cities in the last 6 years, is that they did not think about that in the first instance. How do we share data properly? And I guess, as I say, as Ewan just mentioned, there's some fantastic people on this presentation, and all we need to do is collaborate properly to deliver something for the city leaders.
Yeah, thank you very much for your good ideas and opinions. We need some common playground and working together for offering good interoperability and interworking functionalities. Thank you very much. And it's almost time has gone, but I will go to topic 3. And I think Dr. Ho-jin is there, and I would like to ask to Dr. Ho-jin. He's very actively working at the SC25, and there are many international standards already made. And I'm asking, in the future, SC25, there are many standards, and do you think we need to interwork with other protocols like Meta and HCA and the other things, OCF?
Yeah, thank you, Chairman. As you said, the main topic in the discussion is interoperability or the interconnectability. So I am representing S25 here. So I would like to introduce a technical approach of JT's 1S25 for this interoperability issue. S25 has been working very long time until now to provide interoperability between many heterogeneous devices or the systems. Initially, the device-to-device interoperability was addressed by the 1812 series by United States. And recently, the system-to-system interoperability is being considered now. So the related standards are being developed in S25 now. So actually when the Matter and OCF and HCA are introduced in the home, they are technically built in a form of independent home system, not in a form of individual devices. So users surely require integrated service through the collaboration between the home system, for example, the Matter and OCF HCA. So to support this, the collaboration or interoperability, S25 is preparing the new standard that provides interworking channels between the heterogeneous or various home systems. Also, this standard enables the users to access and manage the home system with a single user interface. This standard is called the ISO/IEC 10192-4 series that is proposed and being read by Korea. So I think that through this framework proposed in this standard, the various standards such as Matter, OCF, or HCA could be interconnected and integrated to each other. So I recommend you to consider this standard as one of the solutions to the integrate or interop issue. Yeah.
Okay. Thank you very much for your good information. It's very informative. And I think now it's time to wrap up my session. I think today's presentations and discussions give us a good chance to think about what we have to do and what we can do in the future for providing real smart home services to the people, including ourselves. I would like to suggest to build up any kinds of discussion groups to know each other well and promote activities for the better interoperability at home. thank you very much for today. Have a good time and have a good health, especially. Thank you.
Thank you very much.
Very much.
Okay, Keshi, Byung-hun, can you wrap up?
Thank you very much for joining us today, and especially appreciate all the speakers and moderators also. Today we got new issues, and soon we expecting to meet again with the upcoming issues. Thank you very much for joining us, and have a nice day. Thank you.
Okay, thank you. Thank you very much.
Yeah.
Thank you.